नहीं।
থাকবে?
হ্যাঁ,
আচ্ছা, ঠিক আছে।
মানে ওদের জন্যই ইনঅগারেশন। স্যার জয়েন করছেন, বিসি স্যার জয়েন করছেন। আমরা একটু ওয়েট করছি, পার্টিসিপেন্ট আরেকটু বাড়ুন।
নরেন্দ্র মোদী আবার তাদের হাত ধরে
জয়েন করেছেন বলছি। ওই তো বিসি স্যার জয়েন করে
আপনি গাড়িতে জয়েন করেছেন?
হ্যাঁ, আমি একটু খড়গপুর আইআইটিতে যাচ্ছি আর কি। রাস্তায় আছি আর কি।
তাহলে এবার আমাদের শুরু করে দাও। কে এটা কন্ট্যাক্ট করছে? কে? সুন্দরতা? হ্যাঁ, তো শুরু করে দাও।
70 participants have joined. শুরু করে দিচ্ছি।
আর কেউ আছে আসার, মানে সেরকম ইনঅগারেশনে কেউ আসার আছে?
ইনঅগারেশনে ডক্টর দেবাশিস মজুমদার উনি এখনো আসেননি, উনি প্রথম স্পিকার।
কে আছে? মানে আর কোনো
কি স্টার্ট করে দেব ডক্টর হিনা?
হ্যাঁ, শুরু করে দাও। ওনারা তো গাড়িতে যাচ্ছেন, কানেকশন তারপর কোথায় কেটে যাবে। হ্যাঁ, রাস্তায় রয়েছেন তো, যতক্ষণ কানেকশন আছে তার মধ্যে দাও।
Very good morning to you all. A hearty welcome to all the dignitaries and participants to this 5-day online workshop on artificial intelligence and its applications, starting today, that is the 16th of November, up to 20th November 2020. We have around 111 registered participants in this workshop. Our university, 1MAKAUT, and CDAC Kolkata is jointly organizing this workshop on artificial intelligence and its applications, in which tools and case studies will be demonstrated and knowledge on current industry trends will be disseminated. The topics on natural language processing, robotics, machine learning, and deep learning based applications will be deliberated. The Center for Development of Advanced Computing, that is CDAC, is the premier R&D organization of the Ministry of Electronics and Information Technology, Government of India, and carrying out R&D in IT, electronics, and associated areas ever since its inception. CDAC Kolkata focuses on the aspects of electronics and IT with interdisciplinary cyber-physical systems, artificial intelligence, machine learning, and sensor and sensing techniques apart from others. Our university, that is Maulana Abul Kalam Azad University of Technology, West Bengal, is a state government technological university in West Bengal, which was founded in 2000 and has about 192 affiliated engineering colleges all over the state. The university provides facilities for the quest of degree and advanced level courses in engineering, management, and other professional areas through affiliated institutions and in-house departments. In today's inaugural session, we are privileged to have with us the Honorable Vice Chancellor of our university, Professor Dr. Shoykot Moitro, who has been playing a pivotal role in mentoring and inspiring us to organize these kind of events. We are also privileged to have with us Dr. Nabarun Bhattacharya, Senior Director and Center Head, CDAC Kolkata, to grace the inaugural session. We also have with us Dr. Hina Roy, Joint Director, CDAC, who is also the joint coordinator of this program along with me. In today's program, we also have with us from CDAC, Dr. Shoma Mitro, Senior Director of CDAC, Dr. Alokesh Ghosh, Associate Director, CDAC, and Dr. Shongit Shaha, Senior Technical Officer from CDAC. On behalf of our university, we have our information scientist, Dr. Mohammad Akhtabuddin, with us today. Now, to begin with the inaugural session, I would like to request our Honorable Vice Chancellor, Professor Dr. Shoikat Moitru, to please address the gathering.
Thank you, Dr. Sundatta Chakraborty. So this is a great occasion that for the first time, with one of the premier research institute of India, CDAC, we are organizing a collaborative program, and that is to in a very important area, artificial intelligence and its application, which is has become this the call of the day, because as we are observing in the last few years, the world is undergoing a significant transition. And we are all going to enter a new world with new norms and new cultures and all these things. And there, one of the major role or one of the major influencing factor that will be artificial intelligence, because most of our things, most of our activities, most of our endeavors that will be happening in digital platforms. And artificial intelligence, the various domains and various areas of artificial intelligence will be playing a pivotal role in making this activity very effective and result bearing. So we are seeing in many areas, but in education, in industries, in commercial, these transactions, in administration, in every sphere, it is penetrating. So innumerable applications are being appearing day by day, and now we have to take leverage of all these things. And that's why we need a massive collaboration among us, because this is such a vast area, and so many different areas of expertise is required. It is not possible for a single university or single institute to take benefit of the entire artificial intelligence in a single standalone manner. That's why this culture of collaboration, networking, it is appearing day by day. We need to integrate our wisdom, our expertise, our skill, our knowledge for making it very formidable, for making our next generation, this world trained in different, these areas, different, these domains of artificial intelligence, so that they can take up the challenges of the future. And in this country, we have one of the biggest advantages, our demographic dividend. Number of young population is very high. And now the time has come that we should take all efforts in empowering this young generation with the right set of knowledge, right set of futuristic knowledge. And there, this culture of collaboration, in that context, we need to follow. And I'm very happy that already we have started initiatives from our university, our faculty members, our officials. They are actively involved in this, and we are getting very warm response from other institutes as well. I'm very thankful to Dr. Navarun Bhattacharya, director of CDAC, because he is very enthusiastic, and we had lots of interaction with us. We have identified several areas where we can work together for the benefit of the society, for the benefit of the community, for the benefit of our next generation. And I'm hopeful that everything will happen in the shortest possible time in near future, because time is moving fast, and every areas we are seeing a phenomenal this growth and development. And that's why we have to also stretch ourselves in all our efforts in this catching up all this changing scenario. And there, artificial intelligence, these areas, more and more these training programs and workshops and organize. It is always better for our learning, say, this community, our students, our researchers, our all these even the community people also, because there are many areas where we should know. We should know as a this common man, as a professional man, as a person of belonging to other disciplines. We should know all these things. So with this, I believe that in the next 5 days, there will be lots of these useful things to be discussed and deliberated by all the experts. from CDAC, and will be, this coordinated and augmented by the faculties of all universities, and this will be of immense help to all the learners. And this is the initiation, and we want to take it to the next level also. And in near future, also, we are planning to organize a series of these types of programs, and of different levels, different lanes, different diagnosis in different areas. And I believe that by all these activities, what will happen that the collaborated endeavor or concerted endeavor will help this country also to move ahead and to improve this, all these economic propositions or state of affairs of all the common people, of all the these citizens, of all the and at a larger context of all the in the entire world also. This is the right time to work on it. So with this, I'd like to conclude, and I've taken seriously, this from my core of my heart. I am expressing my gratitude and thanks to the organizing team from my university, CDAC, and my best wishes to all the participants who have assembled to gather knowledge, and keep this enthusiasm at the highest possible level and engage yourselves in meaningful learning from all these experts who will be sharing their experiences and wisdom with you. Thank you all.
Thank you very much, sir, for your motivation. I would now like to request Dr. Nabarun Bhattacharya, Senior Director and Center Head, CDAC Kolkata, to kindly address the gathering. I think there is some network problem.
We ask Dr. Aptapur to continue, and when Dr. Nabarun Bhattacharya will be able to join further, you can request him to share his view.
Who has joined?
Dr. Nabarun Bhattacharya joined.
Yes,
Yeah. Just it got cut. Now I think VC's speech has been over, isn't it?
Yes.
Oh, okay. So should I speak now?
Yes, we request you to kindly address the gathering.
Okay. Good morning and welcome. It's very heartening to note that we have got more than 100 participants in this very new kind of workshop. And first of all, welcome to all the young students and researchers who are going to participate in this special workshop jointly being organized by CDAC and MAKAUT. Now, I like to draw your attention to the very theme of this workshop, which is not only AI, but AI and its applications. And the very essence of AI, machine learning, and the IoT, robotics, cyber physical systems lie in what kind of applications they are actually deployed for. And these believe that applications developed in US, applications developed applicable for India or West Bengal or the northeastern states or southern India. So AI needs to be crafted appropriately for the Indian applications, and only Indian institutes, Indian students have to develop those kinds of applications. And in this very workshop, all the participants will get a glimpse of what kind of work in terms of research and development or deployment has been happening in the country for applications of applied artificial intelligence. And that is the real essence of artificial intelligence. It should come to life. And artificial intelligence, all of you know this term has been there for a long time, but the key term in this artificial intelligence thing is intelligence. And intelligence consists of one's creativity, one's emotion, one's sincerity, one's hardworking attitude, and one's honesty. These five integrated together actually anybody's intelligence. And artificial intelligence actually has to be brought into life by human beings only, by making new algorithms, by new way of making a computer to work. And to make AI applications really deployable and useful and meaningful, you need all five combinations in a human being also. Like, one has to be creative, one has to be emotional, one has to be sincere, one has to be honest, and one has to be having the attitude of hard work. Believe me, all if we belong to of this country and this great state of West Bengal, and in this state, in this state, we are privileged to have all combinations of things, all these kinds of traits is there with us. So I am sure this AI driven development is going to be spearheaded by eastern part of our country, and Calcutta and West Bengal can be the hub of national development of AI, especially for industrial development in education, development in e-governance, development in agriculture, development in health, development in so many others, in the financial sector. So development in all the societal sectors. This AI, ML, and the associated technologies like robotics, IoT, 5G, etc., are going to play this real pivotal role. And with this enthusiasm and the positive vibes of participation, I feel definitely this eastern part of our country can be the hub of AI-driven growth for our nationality, for our country. And I'll once again welcome everybody, all the panelists, all the resource persons who will deliver their lectures, as well as those participants for this seminar. And please know that essence of any such workshop lies in interactions. So I'll urge one and all to interact closely with the resource persons when they deliver their lectures. And this is only the start. CDAC is going to associate with MAKAUT in many other future programs, in many other research plans and programs, educational activities, and this kind of activities. So I wish the seminar all the best and congratulate the team of CDAC as well as MAKAUT, who made this very first CDAC and MAKAUT joint program possible. I am traveling actually, maybe my internet is poor, so I apologize for that poor connections. Thank you very much and wish all the best for the seminar. Namaskar, sir.
Thank you very much, sir. Now, I would like to request Dr. Hina Roy, joint coordinator of this workshop, to please give the vote of thanks.
Thank you, Shobhita ma'am. I am audible now?
Yes, ma'am.
Am I audible?
A little bit louder.
Just a minute.
Yes, you
Am I audible now?
speak little louder.
Yes, yes.
Okay. Good morning, everyone. At first, we would like to thank the patrons of the workshop, Professor Shaikat Mitra, Vice Chancellor MAKAUT, Dr. Davarun Bhattacharya, Senior Director and Center at CDAC Kolkata, for the joint initiative to organize the workshop on artificial intelligence and its applications, using tools and case studies to equip participants as per current industry trends. Hope this is the beginning of a long-term collaboration between the two esteemed organizations. We heartily thank to the organizing committee members, Professor Parthopratim Lahiri, Registrars MAKAUT, Professor Devashish De, Director, School of Computational Science, MAKAUT, Dr. Devasis Giri, Associate Professor, Department of IT, MAKAUT, West Bengal. Mr. Devasis Majumdar, Senior Director, SIDAC, Kolkata. Dr. Shoma Mitra, Senior Director, SIDAC, Kolkata. Mr. Sanjay Kumar Chaudhary, Joint Director, SIDAC, Kolkata. Mr. Alokesh Ghosh, Associate Director. Dr. Atri Bhaumik, Finance Officer, MAKAUT. Dr. Mohammad Aftabuddin, Information Scientist, MAKAUT, West Bengal. Without whose support and guidance, this program would not have happened. The most integral part of the online workshop are the participants of the program, both students and respected professors and scholars. Today, we are very proud to have more than 100 participants among us, a large fraction of which was ensured through the active role that the program coordinator, Dr. Mrs. Somdatta Chakraborty, Assistant Professors and HOD Department of Information Technology, MAKAUT, West Bengal, to ensure that we deliver quality content to these participants in every session of these 5-day workshops. We are thankful to all the eminent research personalities who have already demonstrated their excellence in these subjects. They would be teaching like natural language processing, applications of AI, robotics, IoT, mainly the interdisciplinary side of physical systems and its applications nowadays, which is very much required for the industry. Now I pass over the forum to Somdatta ma'am, please.
Thank you very much. So with your kind permission, we can begin the lecture sessions.
Yeah, you can begin the lecture sessions.
In today's webinar, we are really privileged to have with us two very eminent and distinguished researchers and experts in the area of artificial intelligence, Mr. Debashish Majumdar, Senior Director, SIDAC, Kolkata, and Mr. Vivekananda Kundu, Joint Director, SIDAC, Kolkata. So we shall start the first deliberation. Before we begin, I would like to give a brief introduction of Mr. Debashish Majumdar. He completed his BTech and MTech from University of Calcutta in radiophysics and electronics in the year of 1988 and 1990 successively. After that, he joined Philips R&D division as M1 technical staff. He joined there for a brief period and worked in the area of mobile communication. After that, he had joined CERI Pilani, CSIR, as scientific officer and worked in the area of semiconductor device. Finally, he joined CDAC and developed the Image Processing, Computer Vision and Pattern Recognition Laboratory, currently known as Advanced Signal Processing Laboratory. He is currently the Senior Director of CDAC Kolkata and Section Head of Advanced Signal Processing Group. In the area of signal processing, he has 20 papers in international journals. He has 4 Indian and 1 US patent into his credit. As visiting scientist, he has worked at the University of Bremen, Germany, Monash University, Melbourne, Australia, University of Kyoto, Japan, University of South Florida, USA, Stephen Institute of Technology, USA, Queen's University, Belfast, Ireland, UK. He is currently working in the area of quantum information, quantum entanglement, and quantum optics as a member of the CDAC quantum computing activities. I would now like to request Mr. Debashish Majumdar to please start his deliberation.
Screen to share. Just a minute. Screen to share.
Good morning, everybody, all the participants. Hope I'm clearly audible to all of you. Now, before I start the lecture, there are two disclaimers. Disclaimers number one, during the next few minutes or hours, we'll be discussing regarding machine learning, which is basically engineering the cognitive aspects of humans and to translate it into computational model. Emotion is one of the major cognitive aspects of humans. And in today's lecture, that way, you can phrase as, this is the best of time in the sense that we'll be discussing most advanced area of emotion engineering. At the same time, you may phrase it as the worst of time because we are snatching your emotional attachment to the auspicious occasion of Bhatri Vidya. Anyway, the disclaimer number two, as my topic headlines goes like research aspects of machine learning. Now, in the inaugural speech, you heard that the objective of this entire courseware is to proliferate the applications of artificial intelligence and machine learning for different areas of science and technology. But unfortunately, my talk is restricted to the basics level of machine learning. And also, it is unconventional in the
Sir,
way.
can you speak a bit more loudly?
I am, louder, but most probably due to network problem, it is not reaching to you in the proper decibel level.
Okay.
Is it clear now?
Yes.
Hello. Hello.
Yes. Yes, sir. Yes, sir.
Yes.
Okay. So during the next few minutes or hours, I'll be discussing regarding the aspect of machine learning, but not in a conventional way. The reason is that artificial intelligence, as it was in 70s or 60s of the past century, it is not the same as we look into the problem in the modern times. So in modern times, people are trying to understand what is the functionality of brain which generates intelligence to understand it, and then whether it is possible to translate them into algorithms, computational algorithms, so that the intelligence can be imparted into silicon chips. That is the basic idea. And in the advanced countries, already it has been terminalized as neurocomputing. They say it is neurocomputing. That is to understand the neural mechanism of human brain and to translate them into computational algorithm. This is the background of preparation of my lecture topic. With this background, let us start. The contents of the talk includes introduction to machine learning, conventional tools and techniques of machine learning, glimpses of human learning and its algorithmic nature, and finally, I'll conclude my talk by introducing deep learning with deeper promise. Now, as I told you that the machine learning or artificial intelligence was from the very beginning of the history of computation. The history goes back to 1945 when US Thin Man and Fat Man destroyed Hiroshima and Nagasaki with 2 atomic bombs. Then US started thinking of developing much more disastrous bombs using the fusion technology. And in that technology, there are many potentially strong scientific brain were active. One of them was Johnny von Neumann, a plenipotential mathematician who has contribution in all fields of mathematics. In all fields of mathematics, Johnny von Neumann contributed significantly. The idea of Johnny von Neumann was whether it is possible, actually he placed it in the form of a theorem or lemma, whatever you may call it, that whether it is possible to develop a machine which can share the task of boring computation. And that was the starting point of theory of computation. Now, while doing this, it was inherent to the mind of Johnny von Neumann, which he carried out till his last day, that whether there is a significant overlapping between the process of computation and the thinking process in the human brain. When the idea of Johnny von Neumann was translated into machine through the work of Charles Babbage, Vannevar Bush, ultimately discovery of the transistor in AT&T Bell Laboratory by Bill Shockley and his group, and when we got ultimately microprocessor, etc. At the same time, there was two researchers, one from the School of Medicine of Harvard University, that is MAKAUT, and his collaborator in the area of electrical engineering, Pitts. They were thinking of whether there is a similarity between the process of computation by a computer and the human neural systems. Now, MAKAUT-Pitts research ultimately came out with a new discipline, which was known at that time as the artificial intelligence. So with this background, we start the introduction to machine learning. If you notice, there are two distinct terms. One is the machine, the second one is the learning. So we should start with what is learning. I found from dictionary the definition of learning, which is like this. Learning is the act of acquiring new or modifying and reinforcing existing knowledge, behavior, skills, values, or performances, which may lead to a potential change, synthesizing information, depth of knowledge, attitude, or behavior related to any type and range of experience. Now, it's a very philosophical definition, very hard to digest by a technocrat, or to translate this definition into computational model. And also notice that there are certain terms, knowledge, behavior, skills, values, performances, which are absolutely cognitive tasks. And for a long time, psychologists, neurophysiologists, neuroscientists, they were studying to discover the meat behind this cognitive and behavioral aspect of human being. Now, how many of these 5 attributes has the nature amenable for computation, or more correctly, how many of them has algorithmic behavior? This is the central point which we will try to digest during the next few hours. Now, more practical and precise technical definition I could coin. The number one is learning is any process by which a system improves performance from experience. This definition is given by Harvard Alexander Simon, who was endowed with Turing Award in 1975, and also won the Nobel Prize in Economics in 1978. The second pragmatic definition came out of Harvard Alexander Simon again, in the term that in the language as machine learning is concerned with computer programs that automatically improves the performance through experience. Now, at this juncture, if I put a question, what a computer exactly does? Initially, it was thought that computer is a machine which can do computation. And the basic term computation is related to numerical problems. That is, if there is a mathematical problems, then computer can solve that problem meticulously. And if the problem is very large in terms of iteration and all this stuff, the computer can do it in a very, very patient and meticulous way. That is the task of a computer. In fact, the lemma of Johnny von Neumann actually anchored around this definition of computer. That is to share some of the computational tasks to machine, which will not have any intelligence, but it will keep on computing some boring steps of mathematics meticulously to ultimately come out with a solution, which for a man is a huge task. Now, we live in a world, the world I designate as physical world. Now, there are two other worlds. One is the mathematical world. The second one is the cognitive world. The relation between physical and mathematical worlds in the context of computation can be established in the following way. The problems in the physical world generates huge amount of mathematical information, which can be modeled using laws of physics or physical sciences, that is chemistry, etc. There are statistical laws, laws of engineering, laws of biology, and many things. Now, whenever you can model the phenomena of physical world by the laws of physical sciences, laws of statistical sciences, laws of engineering, then you map the problem of physical world into mathematical world. And for a long time, it was the basic model of computation. But as and when the other technological development takes place, then we find that there is another hidden world, the world of cognition, where the ingredients are emotion, perception, aesthetics, creativity, inspiration, art, etc. The question is, it is proven through the lemma of von Neumann that it is possible to share the task of mathematical computation to a computer. Whether it is possible to extend the lemma, whether it is possible to translate the problems of the cognitive world into a computational model. Now the answer is yes, because it is hard reality today that many cognitive tasks is now being performed by computer. Computer can predict psephological results. Computer can model atmosphere very correctly. Computer can do many tasks which are apparently comes under the task of cognition of human being. Now, how it is possible? The first step, map the cognitive world into mathematical world. While doing so, we are inherently assume that cognitive problem can also be modeled mathematically. That is the hidden understanding or hidden assumption behind the artificial intelligence. Now, there is a gulf of difference between the modeling of physical laws of physical science, laws of statistical worlds, laws of engineering by mathematics, and modeling the emotional, perceptual, aesthetic, creativity, etc. into mathematical model. Most of the time, the mathematical model is not strictly numerical in the sense that sometimes it becomes logical computation. I give one example to you. Many of you, I'm sure, at this juncture, I tell you, all the examples which I will present before you will include the problems of vision, because my work is restricted in the domain of vision. But there are other interesting cognitive signals like understanding natural languages, understanding speech, understanding olfaction, etc., which will not be included into my talk, but I'm sure that there are other experts who will present these aspects to you. But my lecture will be exclusively restricted within the domain of vision, one of the very strong and very known cognitive cues available to the computer scientist. Okay. Now, the question is, in modeling cognitive world into mathematical world and finally translate them into computational framework, it needs some logical operation. For that, learning and acquiring experience is an important ingredient. Now, what kinds of problem which leads to this kind of logical computation, I give you some example. Example number one, if you stand on a huge field, the horizon is very, very faintly visible to you, which is termed as the frameless situation. And standing on the field, if you look upside, then you find that the sky is appearing as a dome. Why? Sky is not a dome. It's a, but it appears to you as a dome. Problem number one. Problem number two, whenever you see a straight line in the scene, a simple straight line drawn on a blackboard, very clearly visible to you, when you see, then that is mapped within you, but still you see that is in front of you. Problem number two. Problem number three, how this straight line is encoded in your brain. There is no blackboard in your brain. There is no artist in your brain to draw the straight line. Still you see the straight line from the neural firing. How the geometry of the straight line is encoded in your neural architecture, that is also very important. What kind of computation is exploited by brain to view the straight line in front of you? There are many such tasks available in the literature. It's a very upcoming area. In fact, if you look into Wikipedia, you will find that deep learning, the latest entry in the world of neural computing, it is much more biologically inspired. Wikipedia says it is much more biologically inspired. And the innovator of deep learning, Hinton, who is one of the most celebrated scientists of Google, he wrote a paper in Nature. And the first sentence he wrote that, I don't know how it works, but I tried to mimic it in the same line. A brain can think some of the real world problem. That is Hinton himself declaring that his network, deep learning network, is much more biologically inspired. From then on, people started thinking of how the neural encoding of the human brain can be understood in the proper way, and that can be translated into computational language. To continue the discussion on the physical, mathematical, and cognitive world, I should say that all the features of the physical world considered in this mapping are mostly numeric in nature. In the conventional computation, all the actions and tasks of the physical world considered in the present mapping as mathematical structure and expressible by comprehensive mathematical expression, they are essentially computable. The last sentence is very, very important. In a nutshell, what is our basic assumption is that all the cognitive tasks can be modeled by mathematical way, and finally, they can be translated into an algorithm. But again, I just want to put another question. What is computable? I can give you a computer and I can give you a task, and then I can ask whether Mr. Computer can compute it. Is there any way to define that given a task, absolutely surely it will be computable? Or there are certain tasks which cannot be computed? In a normal way, we assume that any task which can be expressed in a mathematical way are computable. But that is not true. There are many mathematical problems which a computer cannot solve, but a human being effortlessly can solve it. For example, there is a very, very popular theorem given by Euclid that the number of primes are infinite. This is a purely mathematical problem, and within 2-3 lines of mathematical steps, anybody can prove it. But a computer neither can prove it nor can disprove it that the number of times are infinite. So, although it's a mathematical task, it is not computable. Similarly, there are some other examples, or to say counter examples, where the problems has clear-cut mathematical structure, but still it cannot be solved by a computer. Say, for example, let's keep this. Find a number that is not the sum of three square numbers. This is the general statement. This is an counter example. If you put this problem to a computer, the computer will not be able to solve this. Why? The reason is that I take one example. You take three numbers to reduce the search space, 0, 1, and 2, and find a number which is not expressible as the square of 0, 1, or 2. You can keep on calculating this. 0 in the left column, 0 can be expressed as 0 square plus 0 square plus 0 square. 1 can be expressed in this way, 2 can also be expressed. But what about 7? 7 is not expressible as the square of 0, 1, or 2. Now 7 is a small integer. If you take a big integer and give computer the task that find whether it is expressible as the sum of three integers, then it becomes a huge computable task and almost non-computable by any computer. You all know these are termed as the NP hard problems. So at the end of the discussion, we again return back to the basic problem that given a task to a computer, how it is possible to determine, or whether at all it is possible to determine that this particular task, whether it is computable or not. Is there any way, or is there any clear-cut, concrete mathematical description of this problem? The answer is yes. This is another example. Find an odd number that is the sum of two even numbers. Any school student can prove it, but to a computer, it's a very, very hard problem. So I can pictorially present the problem in this way. The task generated in the physical world fed to a filter to find out whether the task is computable or non-computable. What is that filter? That filter is actually the Turing machine, or the Turing's theorem. As per the prescription of Turing, Alan Turing, the great mathematician and physicist, he told, or he expressed his theorem in this way. Given a task, if you are able to convert it into a Turing machine, then that task is computable. If corresponding to any task, the Turing's function is not available, then it is non-computable. I am not extending this discussion because in theory of computation, it is a very well-known fact that Turing, corresponding to every problem, if you are able to generate the corresponding Turing function, then it is computable. And if you cannot generate the corresponding Turing function, then it is non-computable. The second part of this theorem of Turing is that if you find a Turing function corresponding to a task, then automatically you get an algorithm, which are nothing but sets of micro tasks. And all the tasks are, so to say, non-intelligent. That is, as per the Turing's theorem, the algorithm consists of microstates which are not at all intelligent. So that way, the conventional computing problems are non-intelligent. So people started thinking of whether it is possible to impart intelligence into the Turing function. The Turing function, the bottom image is of Alan Turing and the top one is for Johnny von Neumann. I'm not going into the details of Turing function. This is available into any books on theory of computation, but in a nutshell, it consists of 7 tuples. And if you keep on, it consists of a hypothetical tape, infinite memory tape, and only task which you can do is the shift action. And through that, if you keep on proceed further, then ultimately it boils down to a function which is known as the Turing function. For our purpose, it is sufficient to assume that every effective method of computation is either equivalent to or weaker than a Turing machine. That is important for us. What problems can we solve with a computer? Initially, people considered different numerical problems. As I told, gradually, non-numeric problems become subject of computation because of the development of other technological aspects to have cognitive signals available for us. One of them is the decision problem. A decision problem is a type of problem where the goal is to provide the answer in the form of yes or no. That is binary answer. One example is check the arithmetic. Given x, y, and z, is it true that x plus y is equal to z, or is it false? Detecting relationships. Given a family tree T and people x and y, is x a grandparent of y? Can we generate, based on this information, can we generate the reverse tree? Example number 3, avoiding traffic. Given a transportation grid G, annotated with traffic information and a starting location S, a destination D and a time limit T, is there a way to get from S to D within time T? These are the decision problems. How to decide or how to specify a decision problem mathematically? The first problem can be expressed mathematically in this way. Given x, y, z belongs to the set of natural numbers, determine whether x plus y is equal to z. That is the mathematical definition of the problem. With our computational model, we'll feed some string into a Turing machine, and it then might come back to an answer yes or no. If the answer is yes, then we'll get the algorithm to solve the problems. If the answer is no, then it is non-computable, corresponding algorithm is not possible, and it becomes computationally hard problem or non-computable problem. Some strings are accepted, some of them are rejected, and some cause the machine to loop infinitely. At this juncture, again I put 2 questions. Question number 1. Elements of the physical worlds are mass, length, particle, temperature, smell, vision, etc., and etc. Elements of the cognitive worlds are perception, aesthetics, emotion, etc. How is it possible that in the micro level, either perception or aesthetics or emotion can be expressed in terms of mass, length, temperature, smell, etc.? Because ultimately, employing sensor, you can sense the mass, you can sense the length, you can sense the temperature like this. And you should have certain mathematical models by which you can express the macroscopic property which will generate the exact description of perception, aesthetics, emotion, etc. The problem is almost equivalent in physics. In physics, thermodynamics express temperature, volume, pressure, these macroscopic properties by certain empirical formulas. And statistical mechanics, another area of physics, which models them using microscopic properties like mass, time, entropy, etc. Similarly, the problem in artificial intelligence and machine learning lies in the fact whether the cognitive parameters like perception, aesthetics, emotion, etc., those can be modeled in terms of the physical parameter, mass, length, time, temperature, etc., 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 which can be sensed by the sensor. Because ultimately, you cannot develop a sensor which directly measure your emotion. You cannot develop a sensor which directly measure your sense of aesthetics like this. Hidden to the sensing elements, there are certain models by which you sense the mass, laying the fundamental parameters and modeling these fundamental parameters. You can measure perception, aesthetics, emotion, etc. How this is. Now, coming to the end of this discussion, the first part of my lecture, that conventional computation can be schematically represented by this figure. There is an input which is generated in a physical world. That input through Turing machine gets an algorithm. This algorithm is fed into the computer and computer generates the output. So this is the functional relationship between the input and the corresponding output in a conventional computer. But how can we incorporate intelligence within them? Because as I told, as per the prescription of Alan Turing, all the microstates or all the microsteps of computer algorithms are that way non-intelligent. So how can we incorporate intelligence within them? If the answer is affirmative, then what is the process? This is the schematic representation. In the modern or the machine language programming paradigm can be represented schematically by this figure, where unlike the conventional computing, during it has got two different stages. One is called the training phase, the other one is called the testing phase. During the training phase, you must feed to the computer an input, also the corresponding output, so that the input generated at the output will be compared with your required output. If you are satisfied that it is unbiased or errorless, if you are not satisfied, then that error fed back to the algorithm to fine-tune some of its parameters to generate the next step of inputs which are less erroneous. This process continues until and unless you get satisfied, and this can be considered a good starting point of the machine learning. So, in a nutshell, without being much more philosophical, we can say in a technical way that the paradigm of machine learning starts with a computational framework in which there are two distinct phases. One is the training phase, the other one is the testing phase. During the training phase, we fed to the computer three things. Number one, the input which we want to process. Number two, our known output corresponding to certain inputs, and then an algorithm to generate the output. So during the training phase, when the input and the known output are fed together, then the algorithm generates one input and it compares also with our required or accepted output. If it finds that the input generated, the output generated comes within an error budget of my expectation, then it is error-free. Otherwise, if it crosses the error budget, then it fed back to the algorithm to fine-tune some of the parameters of the algorithm, and that is known as the learning process. Again, Arthur Samuel defined machine learning as the field of study that gives computers the ability to learn without being explicitly programmed. Tom Micheli, another computer master, he again defined the well-posed learning problem in this way, which is very important for us. A computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T, that is the task, as measured by P, that is the performance, improves with experience E. There are a number of parameters: the experience E, task T, performance measure P, and then the experience E. Now I put an example to show you what does it mean by the parameter experience E, or what does it mean by the parameter T to define task. What does it mean by the parameter P to define the performance measure? What does it mean by the parameter E, which represents experience? For example, some years back, IBM developed one supercomputer named as Cray, and it is claimed that it is endowed with artificial intelligence programming, which can help the computer to play chess with very experts in chess, that is the grandmasters. But in the ultimate results, Garry Kasparov and other grandmasters with simple effort defeated the computer. Okay, let us analyze the problem. So here, the task parameter T is the playing the game. Experience E, all the movements fed to the computer in terms of mathematical expression. And performance, that is, if the computer play the chess with different players 100 times, in how many times computers own the game. That is the performance index, P. The second example, filtering spam mail. It's our common experience. Google has come out with a tool by which spam mail can be filtered. Here again, the task is to define which mail is spam and which are not spam. The experience is watching level emails as spam or not spam, in how many cases the how it can be segregated, or how it can be delineated. The number or fraction of email correctly classified as spam or not spam defines the index P, which is the performance measure. These are some examples. Now I take a brief and virtual coffee break. If you have any question, you can put the question on the related area of your webinar, etc. I will try to answer it at the end of the session. Okay, coming back to the session. Conventional tools and techniques of machine learning. I'll quickly scan some of the conventional tools and techniques, because I'm sure that every one of you who are working in the area of artificial intelligence and machine learning, you all know regarding these tools and techniques. But I will try to find out how these parameters T, E, P, etc. they comes into a major role to play to solve this problem in the conventional tools and techniques. Machine learning investigates the mechanisms by which knowledge is acquired through experience. That is, how the parameter E that can be modified in each iteration. Point number 2, machine learning is the field that concentrates on induction algorithms and on other algorithms that can be set to learn. This is very important. Let us take an example. But before that, why artificial intelligence and machine learning became very, very important buzzword in the world of technology, particularly computer technology and IT applications? Because develop systems that can automatically adapt and customize themselves to individual users. That is a problem of personalization. At this juncture, I just want to give you one example. You all know that if a wrestler gives the keyword to internet that is light, then all the information regarding the lightweight wrestling comes in front of him. But at the same time, if a physicist put the same keyword light, then all the optics related websites comes in front of him. How this segregation is done by Google, that is any browser? Larry Page, this is called the paging. Larry Page is one of the co-founder of Google, and he's a mathematician. He proved that simply using eigen analysis, it is possible to define a matrix which contains all the personal information of any internet user in terms of eigenvalues. This is one of the trumps of mathematics in the domain of machine learning. This is called the paging, after the name of his inventor, Larry Page, the co-founder of Google's. And in many books of machine learning or statistics, it's actually a problem of statistics. It is described in details. Point number 2, discover new knowledge from large database, which we termed as the data mining, that you are given hell lot of data, their correlation, their interrelationships, information contained by them is not initially known to you, still want to seize the data to extract some of the meaningful information. One example is the market basket analysis and applied in AC machine or car. That is temperature, AC machine change its performance depending on the level of coolness in your room. In a car, speed, automatic speed breaker, etc. can be automatically adjusted. And these are the example of knowledge discovery. Example number 3, ability to mimic human and replace certain monotonous tasks which require some intelligence. I give you one example. The example given here is the handwritten character recognition, but I am not going to that. I just want to give another example. Suppose on a tabletop, there are 2 identical balls, identical in the sense of shape, size, color, etc. Both are black balls, but one is made up of rubber, the other one is made up of steel and painted black on top. Now, whenever a robot hand picks up the 2 balls, then how is it possible to impart the intelligence to make the robot understand that one ball is made up of rubber, the other ball is made up of steel? That is peculiar problem of haptic analysis, and many robot scientists are struggling to solve this problem. So these are the examples to mimic human intelligence and to replace human intelligence into certain computational tasks. And why now it has become the buzzword? Because tremendous development of other technical areas like flood of available data. Nowadays, getting a very high precision camera is not a very big deal. Any mobile camera, reasonably costly, can have good camera. And also the invent of internet flooded us with a lot of data. Increasing computational power, gradually the memory is becoming cheaper and cheaper, computational cost is becoming lower and lower. Growing progress in available algorithms and theory developed by researchers in the field of psychology, neuroscience, computational algorithm, mathematics, physics, and combining all them, we are coming out with newer and newer algorithms. Increasing support from industries. The demand of industries for newer application of artificial intelligence and machine learning is increasing. And that's why today, artificial intelligence and machine learning are becoming the buzzword. Types of machine learning algorithm can be categorized into this way: supervised learning, unsupervised learning, reinforcement learning, recommender system, transfer learning. These are all wiki level information, and I'm sure that all of you are accustomed to this type of term. But I give you one simple example to understand how flexible the human learning is. And the real challenge is whether it is possible to translate entirely the human intelligence into machine language, or is there any upper limit? To start with, I give you an example. We all are well known to visit restaurants from our childhood. Now, whenever we visit any restaurant, we know if we consider ourselves as one entity in terms of computational language and waiter another entity, then we can define the relationship between the two entities in terms of delivering order, getting the food, paying the bill, blah, blah, blah. Suppose in one odd occasion, you visit one restaurant when you had tremendous headache and you request the waiter to arrange some painkiller for you. Now, a completely new ER diagram you have developed within yourself. You never had the experience or learning that a waiter can provide you some paracetamols in odd occasion in a restaurant. But instantaneously, your instinct has guided you to ask for a paracetamol to solve your problem. So this is the huge flexibility available in the human learning. In machine learning, people started with supervised learning. That is, the learning process is guided by some supervisor, which is again an algorithm or data. Then they graduated the learning scheme towards unsupervised, that is, without any guidance, the computer will make itself learn. Then reinforcement learning, that is, time to time, it will gather information from the task space and will change its parameters to make the learning much more suitable for this particular task. And transfer learning, which I now described, that in a different occasion, how the learned system can be modified automatically. The learning process in a computer can be summarized in this way. The task of machine learning is simply to make a computer learn from past experience. The E parameter, which I described earlier, it starts with some random value, some initial value, and gradually it keeps on modifying its value. A computer learns from data which represents some past experience of an application domain, and our focus is to learn a target function that can be used to predict the value of a discrete class attribute, example, approve or not approve, high risk or low risk, etc. Searching this function is the most important task for developing any machine learning algorithm. How to define a target function which will solve a problem through the framework of machine learning. That is very, very important. How to design that function. This is one example. As I told you, that any machine learning algorithm is divided in two phases. One is the learning phase or the training phase. The other one is the testing phase. During the training phase, the algorithm fine-tuned its parameters and to generate some outputs, which is within our error budget of expected output. And in future, some of the data which are not included in the training data, when they are fed, whether the computer generates the output within the required error budget. That is the machine learning algorithm. Take a simple example. Suppose I'm a banker. I have to provide loan to my customers. Now, the customer can be categorized into 4 categories, or say 3 categories. Some of them are high-risk customers whose income are low and saving is very poor. Some of them are extremely low-risk customers whose income are high, represented by the yellow dots, and their saving is high. And in between, there are medium-risk customers. And we have clearly delineated them through some horizontal and vertical lines. It is human represented segregation, but whether the same task can be done by a computer. The data to feed is the income of the customer, and data to feed is the savings of the customer. During the training phase, the computer has to generate some lines so that as a banker, I can be rest assured that through this program, if I calculate whether a person is belongs to low risk or high risk zone comfortably, then the machine learning algorithm performs its tasks in a quality way. Task number 1, given a data, how can we determine how many distinct classes are there? That means in the previous examples, it's a 2-class problem, that is the high risk and low risk. Now, when all the data are available with you, the algorithm need to define in how many classes they are divided. This is the classification or clustering problem in the first step, that I need to cluster the data into different zones so that comfortably the categorization can be done. Task number 2, given clustered data, how a new data can be assigned to a particular class. That is called the classification. And you must be appreciating that clustering is absolutely an unsupervised learning. Given a data and without any other information, the computer algorithm must be able to cluster them into required number of clusters. So it is not being guided by any other information. Once the clustering is done, then the information of clustering can be used to categorize them into different classes. So in a sense, this is a supervised learning algorithm. There are many examples. I have taken a simple example. Suppose I have a flat. I want to sell the flat, and now I gather the information that depending on the size of the flat, what is the price available on that particular zone. It is again region specific. A flat in Mumbai is not as low cost as a flat in, say, Medinipur. So these are the data in the top panel gathered by me, and I need to learn the trend of the data. This is very important. If the data is available with me in terms of process, and the computer learn only the crossed data and the corresponding output. That is, if it is 450 square feet, then this is the price. Then the learning is not complete. I need to know the inner dynamics of the size versus price information, because in the test phase, I may not be endowed or I may not be available with exactly these data. My flat may be 475 square feet, or it may be 1025 square feet, and that data is not available in the training phase. So I need to have the regression chart, which is shown as a pink line in the third panel. Once the regression model is available with me, then we can put any data as the input regarding the size of the flat, and from the regression chart, I can get back the price of the flat. But here you see, the line is almost a linear one, but the data is non-linear, it is curvy in nature. So the appropriate regression chart should be a non-linear one. That is the modeling part. Given the data, how efficient way you can model it, the better is your prediction. That means how better is your training phase modeling, the better is your prediction in the testing phase. Another example, suppose as a medicine practitioner, I collected data regarding the stage of malignancy of tumors. And it is a 2+ problem. It may be malignant or benign, and the data looks like this. The red cross represents the malignant one, and the blue dot represents the non-malignant one, depending on the size of the tumor. It's a very naive example. In actual practice, it is not like so simple. But again, to understand the problem, it is very interesting. So here also, we need to define some regression techniques to classify to understand the inherent relation between the tumor size and the malignancy. Once the regression model is available with me, then for tumor of any size represented by the pink arrow in the bottom image, we can take the decision whether it is malignant or benign. Now, supervised vis-a-vis unsupervised learning. Given the data in the left panel, represented by the feature x1 and x2, it may be the color, it may be the shape of the one is circle, the other one is cross, etc. So whether I can use supervised learning or unsupervised learning. This is the clustering problem. The total data set is available with you. You need to apply the clustering algorithms to cluster them into required number of classes. The class number should not be given by you. If you give the number of classes, then it is the supervised learning algorithms. And if you don't give the number of classes, then it is the unsupervised learning. Now, the most of the machine learning, unfortunately, follow the supervised learning. All the known clustering techniques are supervised. But nowadays, some of the unsupervised clustering algorithms in terms of neural networks, SVM, they are coming up. But the performance-wise, still today, supervised learning are much better than the unsupervised learning. And the question is, even a children can clusters in a better way than any mathematical clustering model. That means we are yet to achieve the full flexibility of human intelligence to develop some clustering algorithms. And that is the challenge to the artificial intelligence and machine learning research community to understand the entire human learning. Say, for example, in this particular case, to solve the class of clustering. And if we can do that, then we can have perfectly supervised clustering algorithm. We are inching towards that in terms of neurocomputing, but it is yet to achieve. This is one of the state-of-the-art research problem to the community of neurocomputing. Now I list different algorithms for clustering. The k-means clusterings are there, hierarchical clustering, multivariate normal distribution, expectation maximization algorithm, blah, 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 blah. Here I can put another question, that to develop the clustering algorithms, scientists has used very sophisticated mathematical tools. For example, in case of k-means, it uses some mathematical definition to define the distance between different samples. Euclidean, somebody use Manhattan distance, somebody use Moholy-Nagy distance, like this. In hierarchical clustering, again, they use the distance. In case of expectation maximization, they use statistical calculations based on certain probability space defined by certain distribution function like this. But my question is that, as a human being, solve the same problem, even a children can solve the same problem. Who is the mathematician sitting on the brain of a child to solve this problem? Is there any mathematician in the brain of a children to find out the distribution, to find out the distance, Moholy-Nagy distance or Euclid distance, etc., etc., etc.? So, as I started with, definitely we are lacking behind some of the mathematical tools which are being exploited by the human computation. And if we can achieve that, then computational model will be much more mature, much more rigorous, much more error-free. That is the challenge, to develop new kind of mathematics. These are different models. I'm not going into this. I hope in the subsequent lecture series, they will be elaborated. I just give one example, that is the k-means algorithms. Given the data, this is the raw data. I initialize the two centroid, one is blue and red, and compute all the distances of all the samples with respect to the red and blue dots, and keep on modifying them using the centroid methods until and unless my algorithm converges to the required position as centroid of the two clusters. So these are the intermediate results. And finally, they enter into the clusters and I get the cluster center. These are very common things. But how? Is it the way the human brain solved this problem of clustering, this iterative way? Is it the way the neural coding does solve this problem to find out two clusters here? And mind that here we need to supply the k value, that is the number of clusters present in the system. Once I supply this, then it becomes absolutely a supervised learning problem. But human clusterization is absolutely unsupervised. And it depends on the context also. Same set of data in different contexts may have different cluster output. So human can also solve that problem. How flexible you can imagine the human learning. This is the algorithmic description. I'm not going into that. In Duda Hart's book and in many other pattern recognition books, the algorithms are given. Here, as I told, it is the distance of all samples from the centroid, and we keep on updating the centroid using this simple measure. And ultimately, whenever we are satisfied that the cluster centers are adequately adjusted, then the iteration stops. I want to look into the problem from a different angle. Suppose there are 19 balls, and in a one dimension, they are arranged in this way. So I draw a curve, a curve V1. The amplitude of the curve represents the number of balls present within that mode. Mode number 1, it contains 6 balls. Mode number 2, 3, 4, they contains 1 balls. Mode number 4 or 5, fifth node, they contains 10 number of balls, so its height is much bigger. So now look at this curve V1. Does it not looks like a histogram? Does it not looks like a probability distribution? It is exactly the same. And you can say this is cluster number 1, this is cluster number 2, this is cluster number 3, this is cluster number 4, this is cluster number 5. That means clustering problem is essentially can be translated into a problem of multimodal probability distribution. And my problem will be solved if I can find out the mean of each cluster, each node, and the scale factor, that is the standard deviation of each node. If we can solve this, then we can know that there are 5 clusters. The cluster center is here with the spread of this. The cluster center is here, the spread with this, like this. How? From the data itself, we can generate, first of all, the multimodal distribution like this, and then we can estimate the parameters of the distribution. So finally, we boil down to a problem of parameter estimation. That is, the clustering problem is translated into a problem of statistical parameter estimation. And exactly the algorithms which is available to solve this problem is the Parzen window. What Parzen window does? It defines a simple volume element in the entire sample space and calculate the probability with the help of that volume element. What is that volume element? Let us take example. The common way, draw the histogram, but the analytic way is the Parzen window. The Parzen window can be stated in this way. Let n be the total number of sample points, which is 19 in our previous example. This is 6, 7, 8, 9, and 10. So there are total 19 number of samples, which is represented by small n, and V is the volume of the element, search element, and K be the number of sample within that volume. The Parzen window, the technique of Parzen window is quite close to another numerical techniques known as the, another numerical techniques by which you can do the integration. হ্যাঁ না 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 আরে ওই যে ডট ফেলে ফেলে কি হলো I'll give you the name. Very common one. Okay, the probability density function can be estimated as k upon nv. which is scattering problem so the probability can be defined as k upon nv. N is the total number of sample, v is the volume of the computing element, and k is the number of samples falls within the computing element. So this is the probability. So my task is to find out k, because n is known to me, v is known to me. If we can find how many number of sample points falls within the element, then my problem is solved. So this is the volume element. This is one dimension of length h. This is two dimension of length h square. This is three dimension of length h square, h cube. Like that, we can define the volume element in the n dimension space. So this is an example. Here within this volume, there are three number of element available. The volume of R is 6, and total I have taken 10. Total number of, instead of 19 to simplify the calculation, I have taken 10 number of samples. So this way, in two dimension also, we can define the Parzen window. That is, if any element with respect to the center of the Parzen window falls within the length of half, then one counter becomes 1, and if it falls beyond this window, then it is 0. So this counter will ultimately give you the value of k. So from the reading of this counter, we can compute k, and n and v is available with you a priori, so you can get the probability. Once you get the probability, you can analytically define the histogram or distribution function. You can compute the mean of the distribution function. You can compute the scale factor, that is the standard deviation or the variance of that distribution. So ultimately, you get the number of clusters, the cluster center, the spread of each cluster. This is a very well-known algorithm known as the Parzen window. Yes, I just mentioned Parzen window is very close to Monte Carlo algorithm, in which we find the number of sample falls within a region, and from that information we can find different parameters. We can find out the value of integration, we can find the scattering parameters, we can find mobility, etc. Monte Carlo is a very well-known algorithms in numerical techniques, and here Parzen window is a simplified version to that. Here you see within the Parzen window, two sample falls, so k value is 2, because 5 will give 2 in these two cases. Like this. Okay. So suppose I have been able to find out the clusters. Next, what is the separability between two clusters? This is the cluster center that I have calculated. This is the cluster center I have calculated. This is the standard deviation of cluster number 1. This is the standard deviation of cluster number 2. If we find the difference between the two cluster center, and if we find the cumulative length of the two scale factor, then we can find if the sum of these two is less than the distance between the cluster center, then they are well separated. If both are same, then are just separated. If the distance between the two cluster center is smaller than the sum of the two scale factor, then it is overlapping. Why it is so important to find out this? Actually, for any clustering problem, there is a standard parameter known as the Davis-Bouldin index. What it does, it calculates the distance between the two cluster center, and it calculate or compute the sum of the two scale factor and take the ratio. From that, it tries to find out what is the level of separation between the cluster data. But why it is important? Let me give one example, real life example. This is called the intra-class distance, and the distance between the two cluster centers defines the inter-class distance. And you must appreciate me if I tell our requirement will be to increase the inter-class distance as far as possible and to reduce the intra-class distance as much as possible. Once we reduce the intra-class distance, then it increases the compactness of the set. When the intra-class distance is very, very high, then it is less compact. When the data are scattered, and when the distance is very, very small, then the set is highly compact. And we require to develop highly compact classes. And this is one example. This is one paper we published in a journal. From that journal, the result is presented here. It is a problem of face recognition. For a good face recognition engine, it is obviously required that all the faces of the same person with certain pose, intensity, expression variation, they falls into the same class. That means, suppose this man, within the set, there are 5 pictures of the same person with certain pose variation, and the clustering result based on the feature of the faces must clusters all these faces into the same group, is it not? But here you see, this person, some of his faces are clustered in cluster number 1, but 2 faces are misclustered in cluster number 6, along with the other faces. The problem is that then this face will be matched with this face, which is an erroneous result. Here you see 4 faces of the same person belongs to a single cluster, but 2 faces are missing. They falls into another group. So they will be misclassified. So this will generate erroneous result. This is represented numerically here. This is called the confusion matrix. Ideally, we need to have all the elements in the diagonal of this matrix. That means 6, 6, 6, 6, 6, etc., etc. But here you see, for cluster number 1, 3 is available in the cluster number 1 here, but 2 has fallen into cluster number 6. So what is the problem? Because our choice of feature is not sufficient. So we need to modify our feature extraction algorithm to make this confusion matrix diagonal. Once I do it, then the result is something like that. All are diagonal, and that is required for us. So this is one example. By using clustering, we can find the performance of our algorithm to perform a particular task. Now, so far, I have explained binary classes, etc., etc. I skipped some of the slides to enter into some applications. This is the microarray data of gene sequence placed on certain substrate, and the task is to find out where the mutation has taken place. Gene data, you know, terabyte of data constitutes one single gene sequence of a particular human being, and you need to compare with the entire human genome sequence like HN19 or something like that. And that this is a very, very large search space, and for that you need to apply the clustering algorithm to find out different type of misplaced, different type of morphological dislocation taken place within that particular gene. Why? Because that information gives you the impression whether this particular human being will be affected with some sort of ailment or not. This is the example of mRNA expression data, and there are many works of bioinformatics where people use these clustering techniques to identify different error appearing in the nucleic acid sites. This is called the haplotype gene sequencing. Then text categorization. Suppose I belongs to the information cell of a newspaper and I need to document all the news of a particular day into a database so that for future reference we can collect them. Now news can be of different type. One is the sports type, sports news, political news, science news, etc., etc. I need to develop some computational algorithm so that given a digital input of a particular newspaper, it automatically classify news corresponding to sport related information or news corresponding to political information like this. These are the classified data, and for that different algorithm has developed and it is being used. This is another example of recognizing face of a human being present in the scene. You may ask me how this problem can be framed into the framework of clustering. But the answer is like that. In the scene, there are many objects. Sky is there, greeneries are there, water bodies are there, then there are sands, roads, etc., etc. The entire human body can be classified into trunk, face, hands, etc., etc. We need to extract only those pixels which represent human face. That is the problem. Out of all pixels, n by n pixels available in the scene, develop some algorithms which can recognize the pixels which are present in only in the human faces. For that feature extraction, people use hair-like wavelets. They have the commonality with some of the pattern available on the human face. And based on the extraction of the feature of facial feature using the hair wavelets, then we can go for clustering and classification finally to identify the human faces present in the scene. This is the outcome of our own developed algorithms. Again, signature recognition. For that, there are many features. If I am right, there are 27 significant features in terms of the speed of pen movement. There are curves available with respect to the median line, etc., etc., based on which the signature of a person can be identified. And it is a biometric property. Your signature is your property. My signature is my property. It's my personal property. And that personalization is reflected into different features available in the signature. So signature recognition, another problem where people use this clustering and classification. Customer discovery, this is for business analytics. After that, after clustering, we go for classification. What we do? Given the clusters, we try to find out in the test phase, given the test signals, in which cluster they are closer. And then we put them into that cluster. So this is again very known algorithms. Most of you are known. So Fisher linear discriminant analysis, KNN, decision tree, neural network, etc., etc., etc. But the problem lies. Here you see, between two clusters, I have drawn a clear-cut line which can differentiate the two clusters. But the real-life problems are not that easy or not that simple. For example, here there are two class problems, but the class boundary are nonlinear. How this nonlinear class boundary can be generated based on the data? Because whenever the program starts, you are given only the data. You don't know this kind of these things. You have to draw the class boundary automatically based on the information available in the data. There are many parametric algorithms available in the community of pattern recognition. There are statistical algorithms, but the most simple one is the neural network. What is that? An artificial neural, it is artificial because real neurons are much more complicated, and it is known as the macula of Pitts neuron. In real neuron, there is a cell body. The cell body is, around the cell body, there are certain chemicals or fluids available, mostly sodium and potassium. There is a long stretch known as the axon. At the end of the axon, there are dendrites. Through these dendrites, there are certain synaptic connection. These neurons are connected to the other neurons. And the electric pulse generated here because of the exchange of ions with the external fluids of the body, the electrical pulse gets generated, and that pulse moves to the axon through solitonic transport process. That means there is no dispersion. The shape of the neuronal pulse does not get changes through the translational phase. This is called the solitonic transport. Now, what is the massive network available? One single neuron in the brain, they are connected to 10 to the power 11 number of other neurons available nearby. This is the massive interconnection available in our brain. But in computational framework, it is simplified. A MAKAUT neurons are nothing but an adder. That is, all the inputs coming to it gets added in the first part, and when the added value crossed some limit, crossed some thresholds, then this neuron fires. This is the simple computational neurons known as the MAKAUT neuron. And from the firing condition, I told you that generating the function is the central task of any machine learning algorithm. In the earlier slide, here you see this is the function. It is a step function. It defines a two-class classification problem. Class number 1 falls here, class number 2 falls here. So each MAKAUT neuron has the capability to classify samples into two classes. But whenever we interconnect them, we get the artificial neural network. The function, which I told is a step function, can also be modeled as an S function, defined by this function. Whenever v is infinity, then this function drops to 0, so it is 1. So at infinity, it reaches to 1. Again, at minus infinity, this is 1 by upon infinity. 1 is very less with respect to the infinity, so it becomes 0. So another way, it is 0. In between, it is an S function, trapezoidal function. This is activation function used in artificial neural network. There are mathematical description of that. In the middle of 90s, when the perceptron becomes a hot topic in the community of neural network research, then statistical physicists, they found interesting because these problems, the interconnected MAKAUT network has got close resemble with the Ising model, the Ising glass model, spin glass model, and hell lot of physics researcher became interested to that, and many algorithms, Hopfield algorithms, etc., was proposed. But to us, that is not important. We want to understand how intelligence can be translated within this framework, or we need to do some more work to make it tunable, closer towards the human intelligence. So this is the interconnected artificial neural network. This is called the input layer. These are called the hidden layers. These are called the output layers. From here, we get the output. Now, if I explain this architecture from our presented schematic description of the machine learning, we find that in the training phase, the inputs are fed to these nodes. Also, corresponding to each input, we need to supply what are the expected output. So this input, when gets processed through this layer, different layers, comes at the output end, we compare, are the generated output closer within an error budget to our expected output? If it is not, then that error get back to the different layer. This is called the backpropagation algorithm. And by which, what we modify? We modify different weight through which they are connected. This is the learning mechanism. As I told, the performance measure of this network can be modified from the parameter E, that is the experience gained during the training phase. We'll come across that. But here, another thing to notice that all neurons are connected to all other neurons in the previous layers. There is no gap. All neurons are connected. These are not gaps. These are just to so there are intermediate layers. All are connected. That means it is. All neurons in a particular layer are connected to all other neurons in its previous layers. There lies the difference between the human neural architecture and the artificial neural architecture. In human, neuron in a particular layer are not connected to other layers to all neurons in the other, previous layers. That is the difference which was modified by Hinton to come out with the deep learning architecture. That is one of the reasons why Wikistay says that deep learning algorithms are much more biologically closer to human neural architecture. We'll come to that. So I consider a neural network consisting of only 3 neurons. These are the weights. I initialize the weight with some random value. Whenever input x1 and x2 is given, then it generates some output q. What is q? Q is x1 multiplied by w11, x2 multiplied by w12 when they added into the addition part of this neuron. And if it crosses some threshold, this q, then it fires. A very simple model. But this is the equation of a straight line in the feature plane. This is the straight line. So this constellation is actually represented in the feature space by a straight line. Similarly, if we increase the number of constellation, we can increase the number of straight line. If there are n number of neurons in the previous layer, then in place of straight line, we get the hyperplane. That is the only difference. But to geometrically make it simple, I have considered 2 neurons. So what is the function of a 3 neuron constellation? Is to put a straight line. So if we can engineer the gradient and intercept of the straight line, we can draw the class boundary in a nonlinear way. For example, in the classical exclusive OR problem, these are the false output, that is 0, 0, 1, 1, and these are the true. So it is not possible to draw any straight line by which these 2 classes can be segregated from these 2 classes. The only way we can segregate these 2 from these 2 is by drawing 2 straight lines. So the inner region is class number 1 and the entire outer region is class number 2. And these 2 straight lines can be drawn by a simple neural architecture like this. So these are the example of different iteration. And finally, the weights are modified in the back propagation algorithm. Initial inputs are given, weights are multiplied to generate output. Outputs are compared with during the training phase with the expected output. If it crosses error budget, then that error is fed back. This is called the back propagation. Now, mathematically, the error is defined in this way. Expected output minus the output generated by the network and square of that. Why square? Because the expected output could be bigger or smaller than the generated output. To eliminate the negative sign, we taken the square. Once we taken the square, then it generates a parabolic trace. This is the nature of the error profile of any neural network. And since it is a convex function, so there is a definite minimum. So we start with somewhere here, go for gradient descendant backpropagation algorithm to make the error minimize here. Why gradient wise descendant? Because gradient is the steepest change by which a point can move from one to other point in the Euclidean space. In Euclidean geometry, gradient is the highest level of possible speed which can be inserted into a particle to move from one point to another point. This algorithm is developed by Rumelhart and this group. It is known as delta rule, or somebody told it backpropagation. Anyway, this is the same thing, which does the simple task, generates the error in a random way from anywhere and try to gradient descent to reach in the minimum. Once you reach the minimum, then you get your desired result. But the game is not that easy. because in most of the, this is the error expression, which is a parabolic one. Y is equal to x square is equal to 4ay. This is the simple equation of parabola. Now the game is not very simple because the error profile could be like that. So if you start from here, if you get stuck here, your algorithm will find that you are already reached in a minima, but that is not the global minima. Your task will be to reach here. So for that, different algorithm, annealing algorithms has been developed, Boltzmann annealing, etc., by which artificially you introduce some noise so that you can skip these bumps, come out ultimately settled into the global minima. This is the annealing algorithms. The second, brief and virtual copy break. If you have any queries during this part of the lecture, you can put it in the discussion chat box, and I'll try to answer those questions. Now, before I introduce deep learning, just I want to present 2 slides to show you glimpses of human learning and the concept of receptive field related to human vision. As I told, my talk will be restricted within the domain of visual signals because I have not worked in the speech or olfaction, etc. As I told you, in front of you, there is a blackboard or whiteboard where I draw a straight line. That straight line gets imaged into your retina and finally goes back to your visual cortex, and you take the decision that I am visualizing a straight line. But ultimately, these are neural firing. How the geometrical information of a straight line gets translated into neural spike firing configuration is called the problem of neural coding. That is the process by which the geometrical information is encoded into the neural firing. This is the schematic diagram. Here is your lens of your eyes. In front of you, there is a scene, there is a straight line, and the signals comes to your eyes, fall into your retina. There is a fovea, and these are the visual nerves which goes to the visual cortex. Ultimately, here, the neural firing generates the sensation of straight line in your mind. This is the neural mechanism by which a straight line can be perceived by you. This is the schematic representation. And here, there are neurons, cell available here. Subsequent, there are many layers through which these neural information get transformed to ultimately enter into the visual cortex. A simple model of these things is like this. This is the cone cell, this cone cell, and these are the rod cell. The rod cell captures information related to grayness, and the cone cell encodes the color information. Anyway, if we even consider the problem of grayscale processing, that is only the rod cell. These are the rod cells. The density of rod cells or cone cells are much higher than the neurons in the next layer, bottom layer. Bipolar cell, amacrine cell, horizontal cell like this, ganglion cell, etc. These are the different cells. Now, the question is, in our artificial neural network, all the neurons in this layer are connected to all neurons here. These neurons will be connected here, but in human being, these neurons are not connected to all neurons in the previous layer. These neurons are not connected to all neurons here. Rather, the connectionist model of neuron looks like this. These neurons are connected only to these neurons. These 2 neurons are connected to these neurons. These 2 neurons are connected to these neurons. So, with respect to our artificial neural network model, what is the difference? The difference is that some of the connection gets 0 weight, because 0 weight means no connection. And this is implemented in the deep neural network, where all the neurons are not connected with the neurons in the next layers. These neurons, which are connected to these particular 2 neurons, if any signal comes to them, then it creates firing state for these neurons. These neurons will fire if any one of these neurons gets stimulus. These neurons will fire if any one of these neurons gets or receives input signals. These two neurons will fire if any one of these neurons receives input signals. But if this signal gets any input stimulation, it may not fire. It may not fire. Similarly, when these two neurons are stimulated, then this neuron will fire. When these two neurons are stimulated, then it will fire. But it will not fire when they are stimulated or they are stimulated. This is called the receptive field models, and mathematically they are represented by this. All the neurons here, this is the central neurons, they are connected to some neurons with different weight, and it is represented by a positive Gaussian. And to stop the process, where it will stop the receptive field, they create another negative Gaussian, and the ultimate firing state of a neuron represented by a difference of Gaussian signal like this. This is called the neural, mathematical representation of neural architecture related to vision, corresponding to haptic, olfaction, speech, everywhere. This kind of receptive field concepts are available. Mathematically, it is represented by difference of two Gaussian. This is the positive going Gaussian with scale factor sigma 1. This is the negative going Gaussian with scale factor sigma 2. When you subtract them together, you get the Mexican hat type of response function. And naturally, sigma 1, that is the scale factor of this, is much smaller than the scale factor of this. Or sigma 1 and sigma 2, they represent or they possess some relation between them in terms of the ratio. David Marr and Hillray, the two vision physicists, they found from the experimental data that sigma 1 and sigma 2 ratio comes around 1.56. So with this background, we enter into the last phase of my talk, that is deep learning, deeper promise. If you see the deep learning algorithm, may it be CNN or autoencoder, many algorithms are there. Their performance is tremendously higher than the performance of the corresponding computer vision algorithm. That's why people are more inclined to use deep learning algorithms to solve some of the computer vision problems. But the problem is that deep learning requires huge set of data in the learning phase. For example, if you want to use a deep learning algorithm for face recognition purpose, then at least 20 million of facial data will be required to train it. Otherwise, you will not get the required accuracy. This is problem number one. Problem number two is a black box. What is happening within the hidden layer of the deep learning architecture, nobody knows. Nobody ever endeavor to understand it because it's a high stack of hidden layers. One deep learning architecture, actually there is a eliminated word. It is called the deep structured learning. Structured is not used, but it is actually deep structured learning because the number of hidden layers is 75 to 80. So what is that? To make you understand on the basic mechanism of deep learning, I consider a hypothetical problem, a camera which can grab only 4 pixels, not 4 megapixels, only 4 pixels of these gray sets. These gray sets, within different combination of these gray sets, we can generate pattern like this. This is a solid white pattern. This is a vertical black versus white pattern. This is a diagonal white line or diagonal black line. This is a horizontal line. If I want to make an algorithm which can identify pattern number 1, pattern number 2, pattern number 3, pattern number 4, then it's a complicated one. Because if it is a horizontal line, the same horizontal line can be drawn by putting this black pixel upwards and white pixel downwards. If it is a vertical line, then the same vertical line can be drawn putting black pixels here, white pixels here. So only with 4 pixels, so much of diversification. Imagine if it is a real image of 256 by 256, how many different kind of pattern can be generated and how they can be encoded. That's the problem which deep learning solved. For that, they use the concept of receptive fields. What is that? These are the 4 neurons, because my problem is to understand 4 types of patterns. This is the input neurons, which can sense the grayness value of this. And the value of the grayness can be found from this shade card. So this is of value falls into this at minus 0.5 like this or 0.5 like this. So the concept of receptive fields come here, that these neurons will fire only when the corner pixel acquire the value of grayness of 0.5. If it is 0.75, this neuron will not fire. If it is -1, this cell will not fire. It will only fire when the grayness of this corner pixel is 0.5. Similarly, this one will fire only this corner pixel acquires the value 0. This will fire only this corner pixel acquires the value -0.75. This will fire only when this pixel acquires the value 0.75. During the training phase, we ensure it through weight adjustment and all these things. Once this is achieved, then we keep on adjusting through backpropagation, and some of the connectivity becomes 0 even. In that case, this pixel, this neuron may be connected with this and this. It may not be connected with this and this. That way, it ensures the receptive field configuration. I'll show you. Here you see, this neuron is not at all connected with these neurons. The weight has become 0. This weight has become -2, etc. Based on the weighted value, the cumulative value is generated, and from the thresholding curve, whether this neuron will fire or not, that will be decided. So, white link for every positive weight, black link for negative weight, thickness of the line is proportional to the weight state. The difference between the earlier multilayer perceptron and with the deep learning architecture is that in multilayer perceptron, there is no concept of 0 weight. They are always positive. But here, there are negative as well as 0 weight values. So, and this is the squashing function or the S function. And when we calculate the cumulative score, we put it here. And from there, we take the decision whether this neuron will fire or it remains dormant. So, suppose this is the 2-layer configuration with proper trend. You see, this neuron is positively connected with these and these neurons. That means this neuron will fire when this is fired, this is fired. This will fire when this is acquires this value. This will fire when this acquires this value. So this neuron will represent a pattern where these are black and these are white. Similarly, these are connected to this. This neuron will fire with this value. This neuron will fire this value. So this pattern will be recognized by this neuron. This neuron will recognize this pattern. It is connected only with this and negatively with this. That means this is, and the negation of this, some -0.75 of that pattern will be recognized by this. I'll show you in different layer what patterns they can recognize. See, this is the output. This can recognize the horizontal, these things. This can recognize the other one. This can recognize this. This can recognize this. If we increase the number of layers, ultimately, all the patterns possible by the 4 pixels can be classified into different output neurons. This is, in a nutshell, the activity of a deep neural network where the concept of receptive field is acquired. But we are yet far away from the human vision architecture of the neurons. Today, there is no time, but it is an interesting subject to know the structure of the visual space so that we can design much more effective deep learning architecture. The structure of the human, what do we mean by visual space? Visual space we mean, suppose in front of you, there is a 100 feet length stick. but your brain is not 100 feet. That means there is a squashing of the length, but still you can estimate the 100 feet length. Or you are on a hilltop, beside you there is a jeep by which you have gone to that hilltop, and on the hill down there is a bus. Normally, through the logic of geometrical optics, you see smaller size of the bus and the jeep appears larger than the bus, but you conceive the bus is still larger than the jeep. This is called the size constancy. How these are acquired? In a single line, the human, visual space is not at all Euclidean. It follows the hyperbolic nature. It follows all the hyperbolic geometry, not any Euclidean geometry. So the calculation of the distance, the shape, everything is within our brain is governed by the geometry of the hyperbolic geometry. Bolia and Levachevsky, they developed the hyperbolic geometry, and that exactly is true in our visual space. This is a very active area of research in the area of neuro computing and all these things. But I am not going into the details to that. Those who are interested, they can go to the literature survey. A lot of paper is appearing in biological cybernetics, in transaction of IEEE, in physical review E, in Journal of Vision, in Journal of Computational Psychology, in Journal of Computational Biology, etc., etc., etc. But here I stop. So far, what I have tried to share with you that how the concept of machine learning has evolved from the day one of theory of computation. And then I tried to share the idea, what is the modern stage, where do we start? What is the state of the art research area in the area of machine learning and artificial intelligence? How the neural information is get translated to formulate the algorithm for machine learning. But I'm sure that I had been obscured in many ways. If it is fine, or if you find the subject is boring, then that responsibility lies with me. But the subject is really interesting. I strongly believe that in future we'll come across many good illuminating lectures who will generate interest among you in this interesting area of machine learning and artificial intelligence. Thanks you again for giving me so long patience hearing in the odd hours of COVID and in the emotion, siding apart your emotional attachment of Bharti Vidya. Thanks to all of you. Thank you.
Thank you very much, sir. It was indeed a very elaborate and useful lecture on different aspects of machine learning. I'm sure it has been very beneficial for our participants, because there are many students who are students of artificial intelligence and data science of our university. So I'm sure they have been able to gain a lot of knowledge from your deliberation. What I would request you, sir, to please stay with us, because we have another lecture session, so that we can deal with the questions after that. After we complete the second lecture, we can interact with the students.
Okay, fine, that's fine.
Let us start the second lecture session of today. We have with us Mr. Vivekananda Kundu. He is Joint Director of CDAC Kolkata. So before we request him to start his deliberation, I would like to give a brief introduction. He is currently a Joint Director of CDAC Kolkata. His research interests are in the areas of affect computing, machine translation, emotion and sentiment analysis, machine learning for natural language understanding and generation. During the recent past, he has been an active member in a series of consortia-based projects with IIT Kanpur on making automatic English to Bangla translation system following advanced machine-aided translation techniques applied in Angla Bharti, the first of its kind successful MT framework for English to Indian languages. He has received Master of Science by Research from Computer Science Department of IIT Madras. He has published different papers in the field of natural language processing in different forums like ACL, IEEE, and LNCS. He is one of the program committee members of International Conference on Natural Language Processing and was a member of the organizing committee of the workshop ICT and Forensic Linguistics. He was also a reviewer for ICON 2020, ICON 2016, and a sub-reviewer for the workshop on language technologies for Indian social media. I would request you, sir, to please start your deliberation.
Share screen. Share screen. Shows the share. No, it is not. Share. Full screen.
Good afternoon, everybody. Am I audible? Hello?
Yes,
Can you-
yes, yes,
Yeah.
audible.
So today, my topic is on the machine translation technique, technology, and challenges. It is one of the application area of natural language processing and the artificial intelligence. So in this topic, I would like to discuss that why we actually require machine translation system. What are the challenges to develop a machine translation system? We'll share our experience of developing a machine translation system. And we also discuss from the rule-based to the neural machine translation system technologies in this lecture. So to start with, why actually we need a machine translation system? Because machine translation system is very much essential to bridge the digital divide. Nowadays, lots of knowledge are available and encoded in different languages. Volume of text required to be translated currently exiting the translation capacity means that there is huge demand than the supply. So an automatic translation system can solve this problem. Not only in the education domain, but also in the commercial market, it has a huge potential and to enable the broad, the cross-border trades. Because nowadays Flipkart, Amazon, and other e-commerce industries are looking to translate the customer feedbacks so that they can understand what is actually required for their customer. Now, you may say that the machine translation is already a solution product because there is a state-of-the-art technologies are available and many users are using the machine translation system free of cost. But I am here to motivate you that why there are lots of workers still remaining in the machine translation domain, in the domain of artificial intelligence. So let's start with the most popular machine translation engine, Google Translator. Here, I am giving you two examples. First one is it's raining cats and dogs. The translation is actually very good. Musul dhare bishti hocche. Now, if I write it is raining cats and dogs, you can see the translation is changing and it is not the correct one. Why it is happening? Both the sentences are actually the same. I am just simply expanding the apostrophes with the is, but I am getting a different translation in the first priority, though there are other translations are available, but most popular and correct translation is not coming in the first one. Second example, I am playing tabla after playing guitar. আমি গিটার বাজানোর পরে তবলা খেলছি। I am playing football after playing instrument. আমি instrument খেলে ফুটবল খেলছি। So why the machine translation system is not recognized the tabla as an instrument and why it failing to use the appropriate verb that play will be here baja, not the khela. So there are lots of semantics knowledge are required. Though this machine translation system has been using the state-of-the-art technology, the neural machine translation. This has been given for motivating you that there are lots of research work are till now remaining. It is not a complete task. So let me explain that why machine translation system development is a very difficult task. To understand that, we need to know the science of language, which is known as the linguistics. How the words are actually built by combining the individual character, how a sentence or phrase has been we are constructing a phrase of sentences by combining the words, and what is the meaning of the sentence representing by the semantics, and what was the interculatory act or intention behind the generating the sentence. What that means, suppose we are in a dining table and I am requesting you, do you have the salt? What does it mean? It is not meaning that I am asking you the question that whether you have the salt or not, but I am actually asking you to give me the salt. So my intention is to getting the salt, but I am generating a sentence in a different manner. So machine has to understand the pragmatics before translating it. Every time if we want to translate sentence by sentence, it will not give you the proper translation. We need to translate the concept itself. So we also need to know the discourse, pragmatics, semantics, and we need to inbuild all this information into the machine so that it can give you the proper translation. Now we can categorize the three problem areas for which the translation is becoming difficult. One is the ambiguity, second one is the language divergence, and third one is the modern lingua. What is ambiguity? You know, the Bangla is a very much inflectional language. So sometimes the common noun with the common noun jama, we are using the intensifier haswe. And sometimes the total we have a common noun jama. So if you have a Bangla sentence, Amar ei jamai chai, what will be the translation? Does it mean I require this shirt or I require that son of the son-in-law? So we need to interpret that. How we can solve this problem? We require the discourse knowledge. That's what we actually want to mean to translate that sentence. Similarly, lexical ambiguity, notice that in this sentence we are using the same words, but if we make a change in the word position, it actually give a different translation. The pen was in the box and the box was in the pen. Now here the pen is not representing the column. It is basically a area covered by some things to keep the box into it. So we need to understand the domain itself. Lexical ambiguity, like time flies like an arrow, fruit flies like a banana. Now here time and the fly and fruit and the fly, you can see that the fly here in the first sentence is actually verb, but in the second sentence is noun. So if we doesn't consider the parts of speech of the word, the translation will be different one. Both the sentences have the similar kind of words, but the translation will be totally different. Syntactic and semantic ambiguity. Here, the same sentence can represent multiple translation. Fruit flies like a banana. Fruit flies like a banana. Whether the fruit is flying like a banana, like this image, or fruit fly is a kind of machi that, like the banana, we need to understand what the translation is actually trying to say. So we need to resolve it using its syntactic structure. We need to analyze the syntax of the sentence by which we can disambiguate these two meanings. Similarly, for the sentence, pretty little girl's school. Here you can make different kind of interpretation, whether the girl is pretty or the school is pretty, whether the girl is little or the school is little. So given a sentence to generate the translation, we need to consider so many things. We can't directly pick up the word and search into the dictionary and we pick that meaning of the word and combine this meaning. We cannot get the proper translation. It is a hard task. Similarly, pronoun reference ambiguity. We gave the monkey the banana because they were hungry, because they were right. Who was hungry? Monkey or the banana? And who was right? The banana or the monkey? As a human being, we understand that But if we want to teach machine, if we want to incorporate the intelligence into the machine, we need to provide this concept or knowledge while we are going to develop a machine translation system. The same example, so that's why I behave like that. So you can see the two that is actually telling two different things. Next one is the language divergence. When we are trying to translate from one language to another, say from English to Bangla or Bangla to Hindi, we need to understand how these two languages are different from each other. For example, in certain language like Finnish, we don't have any word boundary. A sentence is completely written without any separator. Now, if you want to translate from Finnish to English, you first have to tokenize the words based on your knowledge that where you can split this chunk of character as a word or not, because you don't have space to easily split this word. So this is a problem of agglutination. We need to solve that divergence issue. Similarly, for Bangla or Indian languages, they are mostly free word order. We can say Ami bhat khai, bhat ami khai, all are okay, but in English it is not happening so. So when I am giving an English sentence and we are trying to translate it into the Bangla, we may generate different combination of translation because Bangla is a free word order structure. We need to map this free word order issues into our translation system. In English to Bangla translation, you can see in the example, Ram is a good boy, very good boy. We generally say Ram khub bhalo chele. We don't say Ram ekti khub bhalo chele hoy. We are omitting ekti and hoy. But in English, the a is present. Similarly, if I say I was in the foreign, I am saying Ami tokhon bideshe chilam. We are or bideshe. We are not using the verb chilam. Similarly, you can see the same preposition with has been using in the translation, but the with has different meaning into the Bangla. I saw a girl with a beautiful eyes, a boy with a high fever. He wrote a letter with a pen. So every time we are using with, but they have different translation. So we need to know all these details because we need to teach the machine to tackle all these issues. Similarly, you can see in Bangla we use the verb khai for everything. Ami bhat khai, ami jol khai, ami cigarette khai. But in English, they have different verbs for that. Similarly, there is a tiger in the forest. In this combination, you can see when you are translating this phrase, there is a, in Bangla, we are not using the meaning of that. So we need to tackle all these divergence issues when we are trying to develop a translation system. Conjunct verb also plays a vital role. Like sometimes multiple words actually transferred into a single word into the English, like kaj kora, dur ho, nosto ho, etc. And sometimes multiple words in English also have a combined meaning into the Bangla, like honeymoon. We don't use the meaning of honey or moon separately when we are translating. So we need to tackle all these issues when we are trying to develop a sentence. So we have performed a research work on that how we can collect this conjunct verb automatically using statistical based system. Because sometimes a conjunct verb like toiri ho may have different meaning in English. Like ami badi toiri korlam, we will build, ami khabar toiri korlam, cook, ami dress toiri korlam, we will make. So how you can collect that automatically? So for that reason, we have collected English to Bangla parallel aligned corpus. And then we use a wide alignment based model, which is basically a expectation maximization based model by which we are trying to automatically align the English word to the Bangla word. And then we applied the HMM based posterior onto the English sentence. And then we find out which one is the common noun and the verb associated with the sentence. And we applied some regular expression based rule based pattern to extract the conjunct verb. And in this way, we collect the conjunct verb. And while we are deriving the pattern, we also notice some interesting phenomena onto it. Like, not every time the conjunct verb are appearing very close to each other. Like, anubhav kora, English is the feel. But sometimes it may have a long distance dependency. Like, jogajog korun but in between Jogajog and Korun, you may have Khub Taratari. So Jogajog Khub Taratari Korun we may say in Bangla, but in English, the Jogajog Korun will be contact, but and Khub Taratari will be immediately and it will be separated from this chunk. So while you are developing certain rules or you are using the word alignment based model, you need to take care of all of these things. The next challenge is the modern lingua. Nowadays, when we are using the social media, our language is not the English, not the Bangla, not the Hindi. It is basically a mixing of that. We may say it is a English or Benglish kind of language. Nowadays, you can notice there are different kind of film titles like Job We Made. So combination of other languages are appeared as a new emerging language. So when you are trying to translate a text to another language, so you need to take care of these modern lingua issues. So whatever translation algorithms are available, whether it is rule-based or statistical-based or neural machine translation, we need to look inside that what the machine translation system actually required to develop that kind of thing. So issues that we need to handle in a machine translation system is first is the parse of speech. Because consider the sentence, I went with my friend John to the bank to withdraw some money, but was disappointed to find it closed. Now we need to understand whether the bank is actually verb or noun and what does it mean, whether it is a financial institution or whether it is a bank of river. So first thing what we need to extract the parts of speech of individual token. So we need to first resolve whether bank is a noun or verb. Then to resolve this parts of speech, it is basically a search problem. You have a start state and you have a goal state, and you have different way to reach from the start state to goal state. And it is a decoding issue. You can apply different kind of AI algorithm to decode or offer your most appropriate search phase where you can reach from start state to the goal state in a quicker time. So if you try to develop a post-trigger and you are considering the hidden Markov based model, so then your observed sequence will be the words like O, Larka, Khaya, and hidden state are actually the parts of speech tag. So suppose in English or Hindi, you have different kind of parts of speech like determinant, noun, verb, etc. Your task is that you have a observed sequence like a Hindi tokens, O, Larka, Khaya. You have to find out whether the O is a determinant or noun or verb, Larka is a determinant, noun or verb, Khaya is determinant, noun or verb. So it is becoming a list. So you have an observed sequence, these are the words, and these are the hidden state. So your task is to find out the appropriate parts of speech tag for individual token. So what we can do, we can apply a hidden Markov based model where three kind of probability are actually used. One is the initiation probability. That is, what is the probability of determinant in the first position and O as a determinant. And second one is the transition probability. What is the probability that the next word, next tag will be determinant after the determinant, or next tag will be noun after the determinant. And what is the emission probability? That what is the probability that a noun can emit a word Larka. So in this way, we can calculate and find out the most argmax out of this combination. And you can know that it is a huge search space. You have to find out the optimum solution in a very small time. So you need to apply decoder here. So there are different kind of decoding algorithms are available, like Viterbi are available, beam search are available. You can apply one of these and you can find out what is the appropriate parts of speech for a particular word to solve a translation problem like we have discussed here, whether bank is a noun or verb. Next issue is the name entity. What is the name entity? Name entity is the name of a person that may appear into the sentence, and we have to decide whether we'll translate or transliterate the name. For example, we may have the name of George W. Bush. Now here we need to understand whether Bush is meaning to a Jhopchar or Bush is a name of a person. So we need to understand whether the Bush is appearing as a name entity or not. So here we can also apply a machine learning type of classifier, and conditional random field is applied for identify the name entity recognition. So The machine learning can be applied from one-to-one end-to-end translation, and also you can apply it as a component-wise, whether you want to try to determine what is the first speech of a particular word or what is the name entity of that of a particular word in this way. And the second issue is the word sense disambiguation. Word sense disambiguation means we want to try to understand the meaning of a particular word. For example, here we try to understand whether the bank word is actually representing a financial institution or it is a bank of refund. So to understand that, we have to apply the word sense disambiguation module here. Next one is the co-reference. Co-reference means here you can see the last one, it is a long sentence we are trying to translate, and in the end of the sentence we are writing that find it close. So what does it representing? Whether it's representing to John or it is bank or it is money, we have to determine that. So for that reason, we require pronoun co-referencing problem resolution module over here. And finally, we also need to identify whether some subject are implicit here or not. For example, in this sentence, you can see, I am not mentioning the subject I here. It was implicit. Because if you are trying to apply any word alignment kind of algorithm like the expectation maximization algorithm, and you are trying to align, given a parallel corpus, you have given a English parallel corpus with the Bangla parallel corpus, you are trying to map with individual word to the meaningful word. And now you don't have the word present itself. So it will give you a problem during this word alignment. So these are the basic steps that we need to handle, whether we are building a rule-based machine translation or statistical-based machine translation or neural machine translation system. So depending on the application of algorithm, we can categorize a machine learning machine translation approach into broadly two categories. One is the knowledge-based, another one is the data-driven. Knowledge-based is the rule-based. Rule-based also has two parts. One is interlingua-based, another one is the transfer-based. And machine learning-based has three parts. One is the example-based, statistical-based, and recently the state of the technology is the neural machine translation. So if we consider the machine translation trinity, in the horizontal axis, you have language pairs. In the vertical axis here, you have the different kind of transfer based on which you are trying to apply the technology, like interlingua based or semantic level or syntax level or direct level, where we are trying to transfer from the source to target language. And another one, to solve this problem, what kind of approach we are applying. We are applying rule-based, statistical-based, example-based, or hybrid. We need to determine. So combining all these issues, we have to solve the problem. Because if you go to the language pair, you will have different kind of linguistic perspective you have to consider. If you're going to level of transfer, you have to consider the time perspective, the execution speed, all this kind of required. And if you're going to go for the technological perspective, whether you are using the neural machine translation or hybrid approach, you have, or simple rule based, you have to consider. So considering these three axes, we have to solve this tree. So any kind of machine translation is basically use this kind of triangle, where this line is representing the analysis, the tasks of natural language understanding, and this sleeping line is actually representing the generation, natural language generation. So it is the natural language understanding axis, this is the natural language generation, and here is the transfer. So you have a source sentence here, you have a target sentence here, you want to translate it. And intermediate is the interlingua. After analyzing the sentence, you are making some kind of symbols by which you are representing the sentence. Then from this representation, you are generating another language. So if you make a direct transfer without considering the interlingua, then the task will be very hard, because if you're going for the statistical based system, you may require parallel corpus for English to Tamil, English to Telugu, English to Hindi, all kind of combination. Or for the rule-based system, you require the total kind of linguistic knowledge for every pair. And if you go for the interlingua-based approach, you will have a common representation, symbolic representation of the source language, and from this representation, you are going to translate to the other language. So I am giving you an example, and I am showing you how we can make the transfer. So say we have a sentence, Ram plays football. So we want to translate it from direct transfer basis without moving towards up into the triangle. So we are consulting a dictionary. We will not find the word ram, so we'll transliterate it, and then we'll find the word play. And we know that there are different kind of meaning of play. Like play means khela, baja, nato, and football has a meaning football. So if I make a direct translation without analyzing the sentence, you may get three translation: Ram football khele, Ram football bajai, Ram natok football. Now, if you move upward to the syntactic analysis, then you will analyze individual word. Now here again, you can apply rule-based technique, or you may apply the HMM-based model to identify the parts of speech tag of individual word. And then we are trying to find out that whether given a grammar, context-free grammar or context-specific grammar, whether we can parse the sentence or not using certain kind of parsing. So you can see that play has two parts of speech. One was the verb, another was the common noun. Now here, when we're trying to build the tree, construct the tree, the common noun has been removed because we doesn't have any kind of rule to parse the tree. So the translation, number of translation we are actually reducing here. So we have two translation, Ram football khele and Ram football bajai. Till now we have not resolved that whether football can be played or can be khela jai or bajano jai. So next one is the semantic level transfer. So we are moving upward to the triangle, and we have a ontological tree, and from which we are trying to analyze the expectation and valency of a verb and the noun association. For example, you can see that khele is a verb which expects the subject as a human and object as a thing, but the instrument can be expect a subject like a human and object like instrument when it will be baja. So using the semantic information, you can come across a single translation that Ram football khele. So in this way, if we go upward again, so you can make a representation of the given English sentence, and you can find out all the necessary linguistic information, whether you are using a simple rule-based approach, like you are using a horn clause to find out all the necessary information, or you are using some statistical modules to gather the information, and you can generate a interlingua out of that. And from this interlingua, you generate the target language. So in Indian language machine translation, there are different kind of machine translation systems that are available, like Angla Bharati, Sampork, Anuvadak, Mantro Rajbhasha, and they have used different kind of technologies for translating. Angla Bharati was initially a pure rule-based system that has been proposed by IIT Kanpur, and later it was approached as a hybrid approach. But like during time of text generation, we have applied the language modeling approach, because sometimes rule-based approach, you know that it generates multiple translation. Now to find out which translation will be the best for the user, we may apply a language model to find out which combination of word or joint probability of the word will be the best probable for that given translation system. Similarly, Mantro Rajbhasha is a purely rule-based system, and their grammar formulation is different. They use the tree adjoining grammar. Now, we have developed a machine translation system, and it has been quoted in the TDILDC website, and it can translate from English to multiple Indian languages like Bangla, Hindi, Malayalam, Nepali, Punjabi, Telugu, and Urdu. Now, while we are developing this language-based translation system, we find out certain observation that machine translation may not give you a 100% accuracy, but it can be used as a translation aid, and how we can use or utilize the user feedback to develop a workbench, we try to do so. So for that reason, I am giving you certain limitation of a rule-based system. Like, consider the translation. My father is an engineer of PWT. Now here you can see the father, translation of father is coming Jono. PWT has been transliteration not in a correct format. Engineer has been transliterated again. And when I am writing arrange the meeting please, now the meaning of please is appearing as a khushi hua or anugroha in the later, but it is not happening in the beginning of the sentence. So as a user, what we can do, we can use a translation memory, which is basically a statistical based model on top of the rule based model, and it is customized for the person specific. As a user, I am logging into the model, and I know that I am translating a day-to-day text. I am not translating a mythological text. So it is not the translation of the Ram was father of Dasharath. Dasharath was the father of Ram. So Janok will not appear here. The translation of Baba should become here. So I am using this translation memory so that in future, whenever I am translating, the most probable selection by the user will be prompt here, and it improves the translation quality. So taking the feedback from the user, we are trying to improving the accuracy of the model. So building a rule-based machine translation system, it has this kind of component. I am very quickly discussing these things, like it has a pre-processor, it has an exception handler, a phrase marker, word analyzer, a sentence analyzer. Finally, it generated PLL, pseudo interlingua. Then it generated output generator, it generate, and post-processor, it actually use the symbol table and generate the output. For example, if I give you the sentence like this, in the pre-processing module, it first identify the number or the rupees, then it make a code and maintain a symbol table, then use the exception handler, it do some pre-processing tasks. Phase marker is actually combining the words together to solve the multi-word expression kind of problem. You know, if we're not combining the access database management, it will give you the individual words meaning. So we have to combine these things. Then the word analyzer basically analyze the word, find out its all linguistic information. Sentence analyzer consult with a parse tree depending on certain CFG rules. And then finally it generates a pseudo interlingua, and it transfers the orientation of the tree according to the target language. For example, you know English is a subject verb object construction, but in Bangla it is a free word order. You may write the subject object verb. So this kind of transfer you require before it sent to the generator engine. Then in the generator, we utilize this information, and from the individual information, we are generating the target language. And finally, we consult the symbol table, and we are generating the translation of a sentence. So this is a basic flow structure of a rule-based system. Now, if I go into the statistical machine translation, how the translation can be done. Suppose that you don't know French. I am giving you this example. Now, I am quite sure that if I give you this example without knowing the French, if you look into the example of parallel corpus, you can easily find out what the word rabbit is actually referred in French. Can you say, you can notice here, in the both the sentences we are using rabbit, and both the sentences we are using the Latin. So, and the three, we don't have using, we are not using three word in the second sentence. And you can see we are using the Grenoble here. So we are already solved. The rabbit is actually mapping to the Latin. Grenoble is mapping to Grenoble. And so three is actually this, and the off is representing they. So without having the knowledge of a language, another language, we can make a translation out of it. So what the magic is going on here? We're using a simple statistical technique here, which is known as the expectation maximization, for finding out the to solve word alignment given the language pair. I'm giving you a very simple example to understand that expectation maximization problem here. You can see in this English we have only 4 vocabulary, A, B, C, D, and French we have 4. So initially, to translating from A to W, B to X, we have equal probability. So we can fill the table with the equal probability. So every word may be translated to other one. So there is equal probability 1/4 can be assigned to your matrix. This one is the English ABCD, and this is for the French. Now, in the second one, we are trying to calculate the expected count of this language pair given the matrix. So we are trying to find out what is the expected count of A to W given the sentence pair AB to WS. And that expected count can be estimated using this equation. So initially T of AW was 1/2. So this is 1/2 into T, sorry, 1/4, because it was equally probable to each of words in the source to target, and divided by A to W 1/4 plus 1/4. And number of time A is appearing in the sentence AB, that is 1. And number of time that W is appearing in the target sentence, that is 1. So in this way, we are calculating the expected count of A to W, that is the 1/2. So in this way, we're making a revision of the table. After that, we are again calculating the revised probability, and we'll get certain probability. And again, we'll repeat the process. Again, we are trying to calculate the expected count. If we make the process continuing in this way until it converge, then we'll see that after certain iteration, the probability value will be saturated, and we will get the higher probability given a number of tokens for the source and the target language. So in this way, you can see the X is actually representing the B. So here X was the Lapins in the French and B was the rabbit. So in this way, using the expectation maximization given a parallel corpus, we may align a source language token to the target language token. Now, if we make an alignment of individual words to the target language word, we can also see the association of the sequences that appearing in the table. So it will giving a clue of phrases. Like you can see, Professor C.N. Rao has been aligned to the Professor C.N. Rao in Hindi, and they are coming close to each other. So you can think that Professor C.N. Rao in English is a phrase of Professor C.N. Rao in Hindi. Similarly, the Bharat Ratna, the two word has been mapped to the single word Bharat Ratna. Se Sammanito has been mapped to the honored with. So in this way, you can create a phrase-to-phrase translation without having the knowledge of the source or target language using simple mathematics. Now, when you are making this phrase table or the word alignment table, then you can generate during time of generation, that is a decoding problem. So you will have a huge trellis. All possibility may be there when you are trying to consult with the table, phrase translation table or the word alignment table. So you are trying to find out which one will be the appropriate during the decoding. So here what we apply the language model. What is a language model? Language model is an n-gram language model which try to find out the joint probability given a sequence of words or phrases. So here you can see Ram ate rice with the spoon. Here is so many different kind of possibilities are there. So we'll try to build a tree out of that, and we'll try to find out which combination of words in the target language will have the higher probability. So we can't traverse all the path because it will be very computationally costly. So we need to prune certain path. So we apply certain kind of decoding algorithm where to find out which will be the optimum path in the trellis. In this way, we can find out the best translation out of that. Similarly, for the phrase-based translation, you can apply the same technique. Now, next one is the factor-based machine translation, where we are not giving the total raw corpus for English or the Hindi, the source of the target language. We also give some linguistic information associated with the word for the better translation. So it is a statistical based approach, but we are also providing certain kind of linguistic information during generation of the parallel corpus. We are giving the information of word, lemma, parts of speech, morphology. So it is quite a complex problem than the previous one. So again, we will follow the same procedure, but the computation cost will be higher than the previous one. So to do all of these things, there are certain open source models are available, which is known as the Moses. Here you can apply the phrase-based, the syntax-based or factor-based model. You have to give the parallel corpus, and you can apply the model, and you can build your machine translation system. Now, till 2013, that methodology has been used, like phrase-based or syntactic-based. But from the 2015 onward, researchers make an evaluation by the Edinburgh University, and they have found there is a new technology is appearing, which is the neural machine translation, and which is giving you a higher performance than the phrase-based or factor-based machine translation system. So what is a neural machine translation? Neural machine translation is basically a simplified model which uses a big artificial neural network. And the basic concept is that given a source sentence, it basically make a encoding of the source sentence and it make a representation of the source sentence. In the rule base, what we are doing, we are using a pseudolingua for a source language by a rule based mechanism. Here in the statistical or neural based model, you are using a neural network. You are making a mathematical model by which you are representing a source sentence into a representation. Here the representation in a vector space, representation of the source. And for this representation, you are applying the decoder and you are generating the target sentence. As it is not so simple as I am showing you here. It is a very brief diagram. So depending on the encoding and decoding, there are different kind of neural network are actually using. So this is a example of a bilingual translation. Multilingual translation also have been using nowadays. So given an English sentence, we are using certain kind of embedding. I am discussing you what is embedding. And from this embedding, we are encoding the English sentence into a vector space, into the source representation. And from the source representation, we are generating the target sentence. So what is embedding? Embedding is basically a technique by which we are basically representing the natural language tokens into the vector space so that it has a semantically, it can make the vector space with, it can appear into the vector space with the semantical meaning. For example, suppose you have a valid sentence, cat sat on the mat, and you have an invalid sentence, cat song on the mat. You know the first sentence is valid, second sentence is not valid. So in this way, you are giving a valid sentence to a neural network, you are giving an invalid sentence in a neural network, you are trying to learn the weights of the matrix, weights of the neural network. And from this weight, you are basically representing the word into the vector space. And this vector space representation actually give you certain kind of meaningful representation, because if you use that TSNE kind of projection in the 2D phase, you can see those words that are basically near to each other, they are appearing into the same locality in the vector space. It has been seen by Hinton and other researchers that applying the vector space, you can solve different kind of NLP problem. So the input to the neural network or deep learning models is basically the vector representation of the word. Previously, it was used that word-to-vec model proposed by the Thomas Nikolov. Nowadays, globe model is used to represent a particular word into the vector space. Now, it also has been seen by the Socher and other team, and they have published a paper in the EMNLP, that if we transfer the word into the vector space in the using the semantical embedding, it has been seen that source and target language, they are sharing the same space. That means here representing a word into the vector space is itself actually aligning the word from source to target language. They have published the paper and source the report for the Chinese and English language. So it actually very much useful for neural machine translation using the globe model and other kind of vector representation of model. So in the machine translation, the researchers are actually using the RNN-based sequence model. What they are actually doing, they are concatenating the multiple neural network in a sequence, but it has a limitation because it cannot preserve the long distance dependency. Because I am writing that the cloud are in the desk. If I say, you may say that is the cloud are in the sky. But if I giving you a very long sentence, like I grew up in France, blah, 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 I speak fluent French. Now you can see the French is associated with the France. It basically quite difficult to understand by the neural network, so-called the RNN model, because there was a well-known problem which is known as the gradient vanishing problem. And that has been solved by the researcher using the latest technology like LSTM or the memory cell. So in the LSTM, long short-term memory they are using. So they have certain gates. By controlling the gates, they are trying to memorize and to try to solve the long distance dependency during the translation model. And when they are trying to translate from bilingual to the multilingual, they also try to keep the representation of the whole sentence, not the final one. So they are also trying to give certain attention depending on the structure of the architecture. So new attention-based mechanism are also appearing in the machine translation domain. But whatever technology are using in the neural machine translation domain, till now there are certain kind of limitation. First limitation is that their structural recording, reordering, or transliteration separate components are not has been used. We can't analyze individually that what's going on into the model or architecture, so that we can simply plug and play with some other kind of issues. We can do it here. Explicit use of syntactic and semantic structure is not possible till now. Explicit use of discourse or anaphora and pragmatic issue has not been solved. As I have given you the example, like do you have the salt? What does actually it mean in the translation? We are translating the concept, not the sentence by sentence. So how we will translate the concept using the neural machine translation is a research issue till now. Now, if you use the neural machine translation or statistical machine translation, you will require a huge parallel corpus. But collecting the parallel corpus is not so easy. Though nowadays there are different kind of news are published in different languages, they are not aligned with each other. We can say they are comparable corpus, not the parallel aligned corpus. So one initiative we have taken in our lab to building a parallel corpus under the project of Euster. So we have used different kind of machine translation system, and given the English sentence, we are trying to translate each of the translation, and our linguist team try to find out which translation system is actually giving the better translation for the source sentence. Now, one research questions appear in our mind that if you have a multiple translation system, how will you know before translating a sentence which translation system will give you the best quality translation? So we have done a research work on that, how to identify a machine translation system from a set of multiple machine translation system in advance, capable of producing the most appropriate translation for a source sequence without having any idea or working principle of the machine translation system. As I already shown you that Google is not already giving you every time the good translation, or Anglavarti is not giving you every time the translation, but you require the correct translation. So as a user, if there are a machine that will support you to choose the translation system for the particular sentence, which will give you the best translation system, that will be very much helpful for you. So how you will understand that before understanding the mechanism of the system or translating the sentence itself? So what we have done, we have framed this problem as a classification problem. As a human expert, what you will do, you will see the observation that I am giving a sentence, I am making the translation by 3 machine translation system, and then I understand, oh, there are some certain kind of phrase, there are some morphological issues on which this machine translation system is giving you the better translation. But if I replace that language expert with a robot, how I can incorporate that knowledge to the machine so that the machine will be able to apply the artificial intelligence to select the best translation system. So that was the real problem. So what we have done, we have framed this problem as a classification problem. We have 3 classes: machine translation 1, machine translation 2, and machine translation 3. And input is the source sentences, like English sentences. From the sentences, we are trying to find out different kind of features. And using this feature, we are trying to build a machine learning engine that can be classified which machine translation system will give you the best translation. So what we have done, given it English sentence, we extract different kind of features, and I am discussing you what are the different kind of features, like phrase structure features, dependency based features, probabilistic features. These are the 3 major category of features we have considered in this task. In the phrase structure features, I try to analyze the different kind of the tree that has been generated during the analysis process, like given English sentence using MALT parser. We are trying to find out the pass of speech distribution, density, maximum number of depth in the tree, the maximum distance from the root to the leaf node, etc., etc. And from the probabilistic feature, we are trying to find out the joint probability. We are using up to n-gram model here, trigram model, n is equal to 3 we consider here. And in the using dependency parser, we are following the model proposed by Sen et al. And here we are trying to find out the dependency distance to build the dependency-based language model. So using this feature, and after collecting this feature, the research questions was, can the feature extracted from the source sentence predict the quality of a machine translation system? Or which machine learning algorithm will be the most appropriate for this classification syntax? And how the selection of different type of feature will influence the performance of the classifier? To answer this question, we use the 1MAKAUT toolset, and using the 1MAKAUT toolset and these data sets, we build a model, we train the model, and we combine different kind of features, and we have seen the combination of SF, DF, and PF, that is structure, dependency, and probabilistic feature, and using the logistic regression model, this system is actually giving you the better performance. Now, finally, we need to evaluate a machine translation system, whether manually or automatically. How you can evaluate it? There are different kind of metrics are available for machine translation evaluation automatically, like BLEU, bilingual evaluation understated, TAR, translation error rate, Meteor, GTM, and text entailment based feature. BLEU is actually overly used in the research community, but for Indian domain machine translation, it had certain kind of limitation, because BLEU is basically a precision-based measure. It tries to measure, given a reference translation and the generated translated, it tries to find out the precision of the chunk generated and you have in your repository. And as I have already told you that Indian language are free word order, we can make any kind of combination, ami bhat khai, bhat ami khai. So this kind of application of BLEU metric is not good enough for this task. So text entailment-based evaluation is recently used, where we are trying to find out whether the generated translation is actually entailed in your repository. So it will help you during the conceptual translation also. In our case, what we have done a manual evaluation, and it was the comprehensibility study. So we have generated a game out of our machine translation engine, and we make this game into different level: beginner, intermediate, professional, expert, and master. And each and individual level have a different complexity of sentences. And when user giving certain kind of translation and machine is generated the translation, we are trying to find out the minimum edit distance between this reference and the generated translation. Using this game in a cloud source mode, we are basically collecting the parallel corpus, and as well as we are trying to evaluate how the translation generated by the machine is actually differ from the manual translation, and to improve our translation accuracy. And also we have done another task that we translate a paragraph, and without giving the source paragraph, we are showing the translated paragraph to the user, and we make certain kind of multiple choice question and give this multiple choice question to the user and tell them to answer this multiple choice question. If the user can correctly answer this question, we'll understand that the translation generated by the system is actually comprehensible for the user. In this way, using manual process, we evaluated our Anglavati system. So till now, we have discussed why machine translation system is very much important, and what are the difficulties lies in the machine translation system. What are the different kind of approach we can use, rule-based to the neural machine translation system, and how to judge a machine translation system. And we have covered all of these things. Thank you very much for your question. Thank you.
Thank you very much for this elaborate discussion on machine translation. Can we take the questions? If Mr. Debashish Mojumdar is also there.
Yes, he is present here.
Okay. So the participants have been asking several questions. Several have raised their hands also. So first we'll take up the questions quickly, because the participants must be hungry. It's past 2 o'clock. So the first question, what is Turing function? This is a question for Debashish sir.
Turing function is actually a mathematical concept. Given a problem, there is a hypothetical mathematical machine which consists of a tape. On the tape, you can store the input variables like a real computer, and only you can do the shift operation, that also in the right shift operation. Say, for example, if I want to solve the problem 1 plus 2 is equal to 3, then 1 as a variable will be stored into that tape, 2 as a variable will be stored into that tape, and through this shifting operation, we will try to converge the problem to get the result 3. Now, there is a detailed mathematical steps by which this Turing function corresponding to given a problem can be generated. In my slide, I showed that it consists of 7 tuples. Why that 7 tuples? Any problem, if you can formulate, and if the problem, the shifting process can converge to the definite answer, then the corresponding steps gives you the algorithm, computational algorithm to solve that problem. This is in a nutshell the Turing function.
Right. Thank you, sir. Next question. How is creativity and aesthetic skill indulged and used in artificial intelligence?
Actually, these are all psychological parameters. Now, the question is, say for example, to quantify the problem, suppose a song which gets popular across India, and there are some songs which never get popularity. So whether we can define some metric by which a song which is very popular can be distinguished from another song which is not very popular. Now, what are the parameters? For example, then you need to extract the features out of that song, and how many number of komal swars, how many number of transition it contains, etc., based on which you can define some metric. But that is very difficult because the problem is not at all 100% mathematically, mathematical model of that problem 100% is not possible. But to some extent, for example, those people who are do the sentiment analysis. Now, given a text, they try to analyze whether the text generates sadness in our mind or it generates some happiness in our mind. But they approach from different way. It is not directly. There is a metric based on which you can declare that the text contains the happiness or sadness. But it is again the ground truth that if you read any novel by Sharat Chandra, some sadness generates in your mind, and if you go through the story of Shivram Chakraborty, then it generates happiness in your mind. But how to attack that problems? These are still research area in computational psychology, in computational neuroscience, as well as in artificial intelligence. And these problems are not yet solved 100%.
Another basic question. How data science is related to machine learning?
Please repeat the question. I could not follow.
How data science is related to machine learning?
As I told, machine learning has got potential application in case of data science. What we do in data science, given a set of data, we just try to extract some of the valuable information out of the data which can be applied for any application. For that purpose, in different stages, in terms of feature extraction, in terms of decision making, in terms of data modeling, and any way, machine translation algorithm, machine learning algorithms are being used at various stages of data science, big data analytics in many ways.
Then there is a question. Sir, can you please elaborately tell about backpropagation? I think we will have a session on neural networks and deep learning later on.
Yes. I tried to present the topic in a schematic way. The reason is that my talk was the first one. And assuming that if I go for deep into any one, then I will not be able to cover many of the topic because my topic headline was Introduction to Machine Learning. Anyway, what I tried to show schematically that when a machine learning algorithm works, then you need there are two phases. One is the training, the other one is the testing phase. during the training phase, you need to put some input as well as the expected output on which you are satisfied. If the generated output by the machine does not come within an error budget to your expected output, then error is generated. That error is utilized and fed back to the circuit to fine tune different parameters of the algorithm, so that in the next iteration, it will generate the output which is closer to your error budget. For example, just now Vivekananda has showed you one machine translation algorithm in which he has initialized his table with probability 14141414, etc. That is the initial step. Now, based on that probabilistic model, he has generated some sentences. From that output sentences, he has again modified the table by adjusting the probability measure. And then the same iteration he repeats, and finally, from the output of the table, he has estimated the correct sentence expected out of this input translated statement. This is exactly the same things. That is, whenever you initialize the, say for example, the weight of a neural network with some random variables, say 0.1, 0.2, like this, and naturally it will generate some output which may not be within your expected output. In that case, considering that error, to calculate the gradient of that error, because error is a parabolic function, I showed it. And if you calculate the gradient on that point, then from that gradient value, you modify the weight. That next time, with the new calculated weight, the output comes closer to your expected one. If you are not still satisfied, then again calculate the gradient of the error curve. With the gradient of the error curve, you again readjust the weight. By this iterative way, you converge to the global minima. Global minima in the sense the error becomes minimum. And if the error is minimum, then the expected outcome and the generated outcome come very much closer to each other. That is, in a nutshell, the steps of the back propagation. And this gradient calculation, etc., is actually using some chain rule, which is a very routine work, does not have any criticality, etc. And I strongly believe that in the neural network lecture, it will be elaborated in details.
Yes, sure. There are questions on Parzen window and gradient descent algorithm also. They wish to know how a Parzen window classifies and what gradient descent algorithm is. So
First of all, the question is should be phrased in this way, because Parzen window never uses gradient descent. Parzen window is a probabilistic calculation. I showed that if you frame the clustering problem, that it is any clustering problem is actually estimation of the mean and standard deviation of a multimodal distribution. I showed it in my slide. Now, how, given a multimodal distribution, given a data, how you can generate, first of all, this distribution? That is the first question. For that, you need to calculate the probability of each sample. The calculation of the probability becomes easier if you use the Parzen window concept. What it does, it actually defines a computing element in the search space. And how many points falls within this computing element, that you count. If you can count that, and if you have the knowledge, the total number of samples available in the search space, you can calculate the probability. That is essentially the task of Parzen window. But gradient descent comes when neural network is employed for the same task. For neural network, because in Parzen window, you need not to give the output a priori. It has got no training phase. In neural network, there are training phase. During the training phase, you modify the neural network algorithm based on the gradient descent. So Parzen window is a classical pattern recognition algorithm which does not use any gradient descent. But neural network is a machine learning algorithm where the feedback loop is there. In Parzen window, there is no feedback loop. It is a conventional computational algorithm. You give input, get the output. In machine learning algorithm, this is not the representation. You training phase, you give input as well as your expected output and adjust the parameter of the algorithm based on the feedback. Whenever this feedback loop comes, then only the gradient descent comes into the picture. So in Pargin window, we don't use any gradient descendant. It is a classical computation algorithm. Straight away you give the input, you get the output. In neural network, it is a machine learning algorithm in which there is a feedback loop. To adjust the parameter of the neural network, you use the feedback loop using the gradient descent algorithm.
We have a question from a student, MPhil student from computational linguistics. I think this question is for Mr. Vivekananda. How can I develop a computational model for language teaching using audio-visual approach?
Yeah, this kind of work also is going on in the research community. This is not only depend on the language processing. It is basically a multimodal approach. This is computational pedagogy, the field where this kind of work is actually going on. There basically the courseware are designing in such a way to evaluate whether the students are easily understanding the language or not. So the computational approach are basically to readability measurement and also analyzing the sentiment and whether the student is actually feeling bored or he is attending the class during the audiovisual session. So image processing is also using, attention-based model is also using, and they are also iris kind of sensor are also using to measure whether the student during the lesson, whether he is focusing on a particular word or his eye is moving from one word to another word. So it is a multimodal approach, not particularly belong to the linguistic approach. And to generate only from the linguistic background to computational linguistic aspect, what you can do, we need to first identify the user for which we are generating the text or building the model. So if my audience are a student for certain age, so we have to find out whether the text generated for them are basically computationally readable or not. So this kind of analysis also we need to do.
Another question, is it possible to write program with artificial intelligence?
Which one? This one? Many programs are research works are going on.
So is it possible to write a program with artificial intelligence?
Yeah, this is going on. This kind of work is already going on.
Okay.
Actually, we use the entire artificial intelligence based framework of IBM to write any program using artificial intelligence. IBM has a open source, a very big kitty of artificial intelligence tools. Using that, you can develop any program. I mean, many programs using the framework of artificial intelligence.
How can we relate neuroscience with machine learning?
Oh, that is that I told, that I emphasized strongly, that this is the new area. People had started understanding that our cognitive process is highly algorithmic. That means they can be translated into computational model. And the newer name of this subject is called the neurocomputing. It has got two parts. One is the neural coding, the other one is the neural decoding. In neural coding part, they try to understand given a task, may it be a vision task or olfaction or haptic, anything, and they try to understand how that task is being performed by our neural structure of animals, and then try to find out the corresponding algorithm and implement into silicon chip to get the corresponding machine learning algorithm. This is a new area known as the neurocomputing.
Ankon Ghosh, a participant, he has raised his hand. So you can unmute yourself and you can ask the question directly. Ankon Ghosh. Ankon Ghosh, you can unmute. Yes. Yes, you can ask the question. You have been allowed.
Ankan Ghosh, please unmute your mic and ask the question. Ankan Ghosh.
Yes, sir. Hello.
Yes, please ask.
Yes.
Sir, I joined about half an hour late, I think, for some technical reasons. So I just take up those lessons previously. Can I get those things?
What is your question? What is your question?
Oh, I understood. Actually, what he wants to say is you could have written. He wants to ask whether we can they can get the lecture materials of the session.
Definitely.
Because
I have given the I have given the slide sets to Ms. Hina Roy, so she can distribute it.
And ma'am, I have a question also.
Yes.
I see a thing, a project called Neuralink. That is Neuralink. Neuralink, a link between neurons for কি ওটা বলে?
তুমি বাংলাতেই বলো, নো প্রবলেম।
স্যার আমি একটা প্রজেক্ট দেখেছিলাম নিউরালিঙ্ক নামে, ইউটিউবে দেখেছিলাম, তো ওখানে বলছিল যে কিছু একটা পার্টিকেল দিয়ে ওই নিউরন গুলোকে অ্যাক্সেস করে বা কোনো ডিভাইসকে আমরা কন্ট্রোল করতে পারবো, এরকম কিছু আছে?
হ্যাঁ, কন্ট্রোল প্রবলেমে নিউরাল নেটওয়ার্ক তো সবসময়, ইনফ্যাক্ট নিউরাল নেটওয়ার্ক অ্যাপ্লিকেশনের শুরু থেকেই কন্ট্রোল প্রবলেম ইয়ে করেছে। কিন্তু তুমি যে পার্টিকেলের কথাটা বলছো, অ্যাকচুয়ালি মেশিন লার্নিং এ পার্টিকেল ফিল্টার্স, হ্যাঁ, একটা ইম্পর্টেন্ট এরিয়া। হ্যাঁ, সে তোমাদের ওখানেই শ্রীয়ঙ্কর ওরা এইসব নিয়ে একসময় কাজ করতো, পার্টিকেল ফিল্টার নিয়ে। এখনো করেন কিনা আমি জানি না, কিন্তু এক সময় আমি ম্যাকাউটে গিয়েছিলাম, দেখেছিলাম যে প্রচুর স্টুডেন্ট পার্টিকেল ফিল্টার, ওই যে জেনারেল ভাইভাতে গিয়েছিলাম, প্রচুর স্টুডেন্ট পার্টিকেল ফিল্টার নিয়ে কাজ করছে। কিন্তু তুমি যেটা বলছো একটা পার্টিকেল নিয়ে নিউরনকে অ্যাক্টিভেট করছে, আমি সেটা ঠিক বুঝতে পারছি না। তুমি যদি লিঙ্কটা আমাকে পাঠিয়ে দাও, আমি দেখে তোমাকে আমি উত্তর দিতে পারি।
হ্যাঁ স্যার, আমি পাঠিয়ে দেবো।
হ্যাঁ, এবং তোমাদের ইউনিভার্সিটিতেই একসময় পার্টিকেল ফিল্টার নিয়ে শ্রীয়ঙ্কর কাজ করতো। শ্রীয়ঙ্কর তোমাদের অধ্যাপক, নিশ্চয়ই জানো। আমি ওখানে ওই একবার অনেকদিন আগে, 4-5 বছর আগে, সেই জেনারেল ভাইভা নিতে গিয়েছিলাম, তখন দেখেছিলাম যে বেশ কয়েকজন ওই পার্টিকেল ফিল্টার নিয়ে প্রজেক্ট করেছে।
স্যার ওই মানে একটা ডিভাইস আর কি, যেটা বলছে ওই নিউরন গুলো দিয়ে অ্যাটাচ করে দিলে আমরা ব্রেন থেকে ডিরেক্ট কোন একটা মনিটর বা কিছু কোন একটা ডিভাইসকে কন্ট্রোল করতে পারবো।
তুমি যেটা বলছো যে আই ব্লিঙ্কার, হাই ব্লিঙ্কার, এগুলো মানে একটা হেড গিয়ার থাকে, সেখান থেকে সিগন্যালটা সেন্স করে ব্রেনে। তুমি সেটা
এরকম টাইপ কি, যেটা ওটা নিউরালিঙ্ক বলে কি একটা প্রজেক্টে কোরিয়ান নাকি?
বুঝেছি। মাউসের যে ক্লিক করছো, মাউসটাকে তুমি যে সরাচ্ছ, সেটা তুমি আই ব্লিঙ্ক দিয়ে করতে পারবে। এইগুলো দেখো, এগুলো হচ্ছে মানে আমি কি বলবো, যে এগুলো খুব একটা মানে রিসার্চ প্রবলেম নয়। এইগুলো হচ্ছে তোমার অর্নামেন্টাল আইটি অ্যাপ্লিকেশন। হ্যাঁ, কিন্তু এই প্রবলেমগুলোর মধ্যে ওই সায়েন্টিফিক যে ইনভেস্টিগেশন, সেইগুলো খুব একটা নেই। এই ধরনের জিনিস তুমি ইউটিউবে প্রচুর পাবে। প্রণব মিস্ত্রি ফিস্ত্রি, ওদের ইউটিউব লিঙ্ক গুলো দেখো। তুমি যদি একটা টেক্সটের মধ্যে কনসেন্ট্রেট করো এক জায়গায়, সেটা অটোমেটিক্যালি ব্লো আপ হয়ে যাবে, এইরকম যেগুলো করেছে। সেগুলো ঠিক এই নিউরো কম্পিউটিং এর আওতায় পড়ে না। ওইগুলোকে তুমি মাল্টিমিডিয়া অ্যাপ্লিকেশন এইভাবেই ভাবতে পারো। প্রণব মিস্ত্রি আগে ছিল এমআইটিতে, বর্তমানে বোধহয় সম্ভবত মাইক্রোসফট বা কোথাও জয়েন করেছে। প্রণব মিস্ত্রির ওই ইউটিউব গুলো দেখো, ও এইসব কাজ মানে প্রচুর করেছে। হ্যাঁ, দেখলে মনে হবে যে খুব সুন্দর জিনিসটা, কিন্তু সেগুলো যে খুব একটা সাইন্টিফিক্যালি মানে ইলুমিনেটিং তা নয়, বাট ইটস ভেরি গুড অ্যাপ্লিকেশন অফ মাল্টিমিডিয়া।
Okay sir, thank you.
Thank you. Okay, Shurab Banerjee, we will take 1 or 2 more questions. We are already running short of time. Shurab Banerjee, you can ask. Please unmute yourself. Shurab Banerjee, unmute yourself.
Surat Banerjee, are you there? Please unmute your mic and please ask your question. Surat Banerjee.
No, ma'am, no question, ma'am, actually.
No question, you had raised your hand. All right.
No, actually.
Please, please let in Aisha. She has also raised her hand. Aisha Datta. Yes. Please unmute and ask.
Ayush Datta, please unmute your mic and please ask
Ayush,
the
yes,
question.
Ayush. Ayush. Please unmute.
Hello.
Yes,
Please
please
go.
ask.
Am I audible? আমার কথা
Yes,
শোনা
yes.
যাচ্ছে? আহ,
শোনা যাচ্ছে, বলো।
বলছি যে স্যার, যেটা হলো যে এই যে জিনিসটা আপনি শেখালেন, মানে আর্টিফিশিয়াল ইন্টেলিজেন্স বা মেশিন লার্নিং বা তার অ্যাপ্লিকেশন যেগুলো, তো স্যার মানে প্রোগ্রামিং বা কোডিং কনসেপ্ট মানে
আচ্ছা, আমি তোমাকে একটা সহজ এক্সাম্পল দিচ্ছি। হ্যাঁ, তুমি প্রথমে একটা এক্সক্লুসিভ অর গেট নাও, ধরে নাও। হ্যাঁ, এক্সক্লুসিভ অরে 4টে আউটপুট হয়, তো 2 ইনপুট এক্সক্লুসিভ অর যদি হয়, মানে দুটো ইনপুট যদি 1 হয় আউটপুট 0, দুটো ইনপুট যদি 0 হয় আউটপুট 0, যে কোনো একটা ইনপুট 0 হলে আউটপুট 1। তুমি একটা গ্রাফ পেপার নাও, সেখানে একটা অ্যাক্সিস টানো, অ্যাক্সিসের অরিজিনটা 0 0, সেখান থেকে 1 ইউনিট দূরে 1 0, উপরে গেলে 1 1, আর এই ওয়াই অ্যাক্সিসের উপরে তুমি 0 1 পাবে। 4টে আউটপুট পেলে, তুমি 4টে কম্বিনেশন পেলে। তাহলে এবার দেখো 0 0 আর 1 1 এই দুটো কম্বিনেশন তোমাকে ট্রু ভ্যালু দিবে, এই ফলস ভ্যালু দিচ্ছে, কারণ দুটোই 0। আর 0 0 0 1 1 0 এই দুটো ট্রু ভ্যালু দিচ্ছে। হ্যাঁ, তুমি তাহলে ক্লাসটাকে কিরকম ভাবে আঁকবে যাতে তোমার এই যে 0 0 অমুক তমুক দিচ্ছে, এগুলো তো সব ট্রেনিং ফেজে। এবার ধরো 0.2 0.8 দুটো ভ্যালু এলো, এটা তুমি কোন ক্লাসে ফেলবে? এই প্রবলেমটা যদি করতে চাও, হ্যাঁ, তুমি দেখবে যে এই ক্লাস্টারিংটা মাল্টিলেয়ার পারসেপট্রন দিয়ে খুব সহজেই করা যায়। এবং ইন্টারনেটে এক্সক্লুসিভ অর প্রবলেম উইথ মাল্টিলেয়ার পারসেপট্রন দিলে তুমি ম্যাটল্যাব কোড, সি শার্প কোড, এটা অনেকগুলো কোড পেয়ে যাবে। তুমি যে কোনো একটা কোড ডাউনলোড করে চালিয়ে আগে দেখো যে ক্লাসিফিকেশন মানে টেস্টিং ফেজে তুমি কত যে ফাইলটা তৈরি করেছো, তোমাকে ফাইলটা তৈরি করতে হবে 0 0 0 0.1 0.1 0 0.15 0.15 0 এরকম একটা তৈরি করে নাও নিজের মতো করে, করে দিয়ে তুমি ওটাকে ট্রেন করাও। এইবার তুমি যে ট্রেনিং এ যে স্যাম্পল গুলো দিয়েছো তার বাইরে গিয়ে একটা স্যাম্পল দাও। ধরো তুমি দিয়েছো 0.2 0.8, তার মানে ধরো 0 1 এর মতনই একটা ব্যাপার হলো, তাহলে আউটপুটটা 1 হবে। এটা তুমি ট্রেনিং ফেজে দিয়ে দিয়েছো। এবার তুমি 0.25 0.75 দাও, দিয়ে দেখো 1 এ ক্লাসিফাই করতে পারি কিনা।
আচ্ছা,
এই প্রোগ্রামটা তোমার ইন্টারনেটে অ্যাভেলেবেল, ম্যাটল্যাব ভার্সন অ্যাভেলেবেল, সি শার্প অ্যাভেলেবেল, এবং যে কোনো তোমার নিউরাল নেটওয়ার্কের বইয়ের পিছনে দেখবে এই কোডিংটা করে দেওয়া থাকে।
আচ্ছা, না আমরা এই ধরনের কিছু করেছিলাম, প্লটিং আমরা ম্যাটল্যাবে করেছি। আমি ইলেকট্রিক্যাল ইঞ্জিনিয়ারিং এর স্টুডেন্ট, ঠিক আছে, কিন্তু আমার একটু ভালো লাগে বলে এই ব্যাপারগুলোকে নিয়ে আমি একটু পড়াশোনা করি।
দাঁড়াও, তুমি যদি করে থাকো এইবার, তাহলে সহজেই তুমি একটা শক্ত প্রবলেমকে সলভ করে ফেলতে পারো। কেমন? ধরো একটা ইমেজ নিলে, ইমেজের মধ্যে এজ ডিটেক্ট করবে, ঠিক আছে? তাহলে এজ পিক্সেল গুলো কিরকম হয়? যেখানে হাই গ্রেডিয়েন্ট হয়,
হ্যাঁ,
আর যেখানে তোমার মানে হোমোজেনিয়াস রিজিয়ন, সেখানে তুমি এজ পাবে না। তাহলে তুমি কিছু মানে পিক্সেল মানে ট্রেনিং সেটটা তৈরি করলে, যেখানে পিক্সেলের ভ্যালু গুলো হাই, সেগুলোকে তুমি এজ পিক্সেল হিসেবে ইন্ডেক্স করলে, আর যেখানে তোমার মানে গ্রেডিয়েন্ট ভ্যালু কম, সেখানে সেটাকে তুমি নন এজ পিক্সেল হিসেবে ডিটেক্ট করলে, করে তুমি নিউরাল নেটওয়ার্কটাকে ট্রেন করলে। এবার ওই ট্রেন নেটওয়ার্কে তুমি একটা ইমেজ দাও। ইমেজটাকে তুমি প্রথমে,
মানে ইমেজ প্রসেসিং ব্যাপারটা দাঁড়াচ্ছে স্যার।
হ্যাঁ, ইমেজ প্রসেসিং অ্যাপ্লিকেশন,
অনেকটাতে ইমেজ প্রসেসিং দাঁড়াচ্ছে।
হ্যাঁ, ইমেজ প্রসেসিং এ দেখতে পারো যে ঠিক এই এক্সক্লুসিভ অর প্রবলেমটা দিয়েই, মানে যেটা তুমি করেছো প্রোগ্রামটা, সেটা দিয়েই তুমি একটা এজ ডিটেক্টর বানিয়ে ফেলতে পারো খুব সহজেই।
আচ্ছা আচ্ছা, কিন্তু স্যার এটা ম্যাটল্যাব ছাড়া অন্য কোনো দিয়ে ধরুন জাভা বা পাইথন দিয়ে কি করা যেতে পারে?
পাইথনও করা যায়,
পাইথনেও করা যাবে। পাইথনে যে মানে তোমার ম্যাথমেটিক্যাল লাইব্রেরিটা ইউজ করে, ওই নামপাই, সেটা পুরোপুরি ম্যাটল্যাব কম্প্যাটিবল। ম্যাটল্যাবের সব সিনট্যাক্স ওখানে নিয়ে নেয়। হ্যাঁ, তুমি ইম্পোর্ট এনপি করে নাও প্রোগ্রামের শুরুতে, করে ম্যাটল্যাবের পুরো মানে সিনট্যাক্সটা লেখো, দেখবে তোমার প্রোগ্রামটা চলবে। খালি প্রোগ্রামের শুরুতে হেডারের ওখানে ইম্পোর্ট এনপি অ্যাজ ইয়ে করে ওটাকে ইম্পোর্ট করে নাও।
আচ্ছা আচ্ছা, ঠিক আছে স্যার, আর বলছি যে এই
ঠিক আছে
আজকে
আয়ুষ,
যে
না
ভিডিওটা
আমি
কি
একটু বলি,
পাওয়া
if-
যাবে?
হ্যাঁ?
মানে এই যে টোটাল যে ক্লাসটা হলো, এটা রেকর্ডিংটা একটু
হ্যাঁ
পেলে
সেটা
খুব
তো
ভালো
স্যার
হতো।
বললেন যে পিপিটি প্রেজেন্টেশন দিয়ে দেওয়া হবে তোমাদের। আহ, আমি অন্য পার্টিসিপেন্টদেরও বলবো, ইফ দে হ্যাভ এনি মোর কোয়েশ্চেন্স, উই আর গোইং টু স্টার্ট আ ডিসকাশন ফোরাম. The link will be sent to you. So if you have any further questions, you can write there and the experts will answer. Okay? Because we have very limited time. So within this limited time, it will be very difficult to answer each and every question. So you can write your questions, you can post your questions, and they will definitely be answered by the experts. Okay. So I think we can end the session today. We would like to thank our experts for such a wonderful deliberation and sparing time from their busy schedule to be with us. Thank you very much. Thanks to both of you. And to the participants also, I would like to tell that please follow these deliberations very seriously, because at the end of, on the 5th day, we will be holding a test. There will be a test, an online test, based on which you will get your certificates. So I would request all of you to follow all the sessions, because the questions will be based on the sessions that you attend. So this is my request to all the participants. And please fill up the feedback form that has been entered in the chat box. The link is there in the chat box. And I think we can close the session today. Thank you all for joining. And tomorrow again, please be with us at 11 o'clock. We will again meet at 11 a.m. tomorrow. That is on 17th. Thank you so much. So we can close the session. Thank you.
Thank you, ma'am. Participants, please take the note of the feedback link and joining link for tomorrow's session. Please take the joining link of tomorrow's session and please note down the feedback link. And we will be back tomorrow at 11 o'clock. So please join tomorrow's session at 11 o'clock. Thank you all for participating. Please take the joining link of tomorrow's session and please give the feedback of today's session.